Hello, everyone.
Hello. Of course, we are having technical issues again, but this time, for once, the technical issues are not on my end. It is instead Tristan's computer that is not working. Uh, but we're going to push through and deal with it anyway, and solve this delightful looking Marty Sears puzzle, uh, which
Also,
I think looks like it's going to be quite cool.
your audio sounds terrible, so that is great.
Well, I guess you get to come mess with that again. I can never really tell if the audio things are in Tristan's head or not. But you were happy at it for a second. Ooh, Plonk time, donating to get Tristan a new mouse for Christmas. Let's get a donation dance for Plonk time. Boop 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 doop boop 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 doop boop 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 doop doop boop boop. Woohoo! Boop doop doop boop 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 doop doop boop boop. Woohoo! Woohoo! Thank you so much, Plonk time. Greatly appreciated. Uh, Thank you. Is it possible, Tristan, that it's because Zoom is refiltering it for you, but it's not refiltering it for chat? And so you're hearing my audio sounding weird, but chat is not hearing it sound weird? Because Zoom, I know, does some auto filtering of audio, but you now have that happening through OBS. And so it might be that it only sounds weird for you, but not because something. Oh, but J40 says something is weird. So maybe it is not just that. Okay, the Jay and Jim both agree with you that something is off with my audio.
Yeah, might need to switch from Zoom's noise reduction to mine, but we'll do that between puzzles.
Tristan, after every single stream, has been like, no, the audio is terrible. I'm going to go get the settings and change all of them. And then does that. And then it's like, now it's different. Perfect. And then comes back and does it all over again after every stream. Since I got the new laptop. By the way, thank you so much, Flunk Time. Really huge thank you.
Yes, thanks so much. Let's see.
It's definitely not as weird as the last time it sounded weird. Yeah, it's because I got a new laptop, so everything's got to be sort of like set up again from from the ground up. By the way, I don't think I clicked the heart. There we go. I'm supposed to click the heart. Now I have clicked the heart. Although interestingly, when you click the heart, it then just turns it to a zetamath logo, which is, I guess, the closest thing to a heart that YouTube has.
Okay. I was so wrapped up in solving the technical issues that I did not then use the bathroom, which I have to do. So I'll be right back.
Oh, it's because my audio is not going through OBS at all. That's why the OBS settings for my audio are not relevant. It's the audio settings on Zoom instead, I think that Tristan is going to want to mess with. Selena predicting that this puzzle will take either 5 hours or 15 minutes, depending on how quickly we spot the break-in. Given there are 43 of us, and at least one of us has solved the puzzle before, I feel good about our odds of getting under 5 hours. I can only see the RENBAN and NABNER definitions, so I don't know what the light blue lines or the red line or the gray line are. I can guess what some of the other lines are, but I'm guessing the red line is a parity line, but I do not know. I can see the top left corner of the rules on my screen, the way that it is, the way that Zoom is cropped for me. Is the gray line a 10 line? The gray line might be a 10 line, but it might be something. It might be a palindrome too. Uh, uh, yeah, Jim, that is so far the how far I have made it is to note that there's definitely a 4, 5, and a 6 in the puzzle, and so because of the length 6 Renban, and therefore the whisper needs to have. I guess the whisper always had needed to have repeated digits, but because the whisper can't have a 5 on it, but there is a 5 in the puzzle, that means something, something, something. We'll figure out what the something, something, something is at some point, perhaps. Uh, gray is palindrome. Okay. And red is same difference. Okay.
Yes. So
I enjoy the name same difference, by the way, just as a title for a constraint. Oh, red is parity, apparently.
can people see how like laggy my cursor is if I like how jerky it's moving?
Oh, turquoise is the same difference. Okay, got it.
Yeah, so this is RENBAN. NABNER is yellow. Blue is region sum. Green is German whisper. Red is parity. Alternating parity. Gray is palindrome. Turquoise is same difference. And then we have Kropke dots. And what are the overall rules? Divide the grid into 8. I can't read that.
Okay, well, neither Tristan or I are going to know what the rules are, but that's okay. We can figure it out together with the chat. I saw that we're using 8 of the 9 digits, and we have to decide which 8 of the 9 digits we're using. And Jim and I have proven that 4, 5, and 6 are 3 of the digits, so we only need to pick 5 more.
Divide the grid into 8 non-overlapping 2x4 regions, which can each be placed either horizontally or vertically. 2x4 regions, okay. It must be determined which one of the digits 1 to 9 is missing from the grid, and the other 8 digits should appear once in every row, column, and region.
Is there a way to assemble 2x4 regions that's not not one of the 2 standard orientations? I guess there is, because I can picture like going down the sides, 2 of them, and then some down the middle. So I guess my original intuition that it was going to have to be just one of the 2 arrangements is wrong. So I kind of want to interrogate the question, do we need to have a 4 or a 6 on the whispers? Can you color the whispers with like O's and X's or grays and light grays or whatever it is you want to color it with?
Yes.
Maybe because the regions are 2x4, we don't need colors for the regions. Okay, so I agree with chat's assessment that the black dot on the whispers is low high, so it is certainly from 3, 4, 6, 8. So there is a 4 or a 6 in one of those cells on the whisper. So either those 2 yellow cells are the same, or those 2 purple cells are the same. Is one of those a problem in terms of our region building? Because I feel like it might be difficult, because my point is one of those 2 cells is a 4 or 6.
Can you indicate which 2 cells you mean using annotations, please?
The ones adjacent to the black dot, because the black dot has a 4 or 6 on it. I can attempt to annotate it, but I think it would be better if you highlighted it than I highlighted it. But it's either these 2 are the same, or these two are the same. And I'm trying to figure out if one of those would break our ability to do region building.
Betting isn't
yes.
open.
So that is a good point. So I think J40's point is that you should draw gray borders in every 2x2 because we can only group like this just through the whole grid. Because our regions are 2x4, we always have to have this 2x2 up here. Those are all in the same region. And the only question is it also in the region with this or also in the region with this? And so if you just draw that through the entire grid, then maybe we'll find the break-in.
That's going to be a really interesting skill exercise, as you can see on my...
There we go. I have successfully cleared my drawings. Let's see. Let's see.
Real apologies to Marty that he's got to suffer through me having technical issues and trying to solve this puzzle.
At some point, we should have just switched to having me solve, but that seemed like it was going to take way more time, given that you'd set it up completely the other way. But if this is completely miserable, then perhaps between the puzzles, although I don't know if we can between puzzles switch to having me solve instead of you.
We certainly can.
Okay, now you've just got to do the rows.
I'm trying to get my cursor down there. We might just have to switch now, because this is not...
Okay, if you need me to do it, you can have me do it, but you're going to have to set it up.
Yeah, so... Oh, sorry, folks. We're going to do this real quick.
Okay, we'll be back with me solving in just a second.
Okay. Big apologies all around. This stream has been quite the disaster.
Is 40 minutes late a new record for when essentially the stream is starting?
Yes.
But we're back now. Can people see my cursor? Does my cursor appear to be moving in a non-jerky fashion with some gray lines drawn in expertly? And chat has basically solved the puzzle. I'm told I sound better as well. Thank you, Jim. I've been working on my vocal exercises. All right, so to summarize what has happened so far, J40 noted that these 2x2 blocks have to go together because our regions have to be 2x4. And so, for example, this cell has to be with these cells because it goes at least 2 in each direction. So all of these are together. But then by induction, all of these are together, and that sort of trickles out to the entire rest of the grid. I could torture you all by saying some proof about evens and odds, but I'm not going to. But basically, all of these go together. So basically, we only have to decide, does this 2x2 go with this 2x2 or with this 2x2? We know that this black dot, because it has a high and a low digit on it, has a 4 or 6 on it somewhere. Because if it didn't have a 4 or 6 on it, it would be a 3-8 black dot, and 3-8 is not a very good black dot. But then it was pointed out that down here, because of the palindrome, these two circles are the same digit, so therefore there's a true region border here. And if there's a true region border here, that means we get a true region border here, and this was a fake region border all along. And so therefore all of this stuff is one region. And so I'm trying to use the black border to indicate that. So as opposed to the gray borders, which are sort of the potential region borders. Now, whichever of these is 4, 6 means that either these two are the same digit and both equal to 1, or both equal to 9, or these two are the same digit and both equal to 1 or to 9. But unfortunately, there's no way that's going to cause a problem with region borders like I had originally hoped that it would. We also know that there's a 4, 5, and a 6 up here. And so we have that. Josh has a good point that I can't make all of this be in the same region, because if I make all of this in the same region, this one digit is equal to the sum of these five, and that's not going to work good. So there's a true region border there for sure. Let's see. Do I know that there has to be one below? No, I certainly could have these three equal to those three. That all seems fair. And I do know that there's a 4, 5, and a 6 on this this RENBAN up here. We have said previously. Let's see. On the short, have to connect the same ends. 5 in row 1, column 7, 8. Yes. So that is a good spot. So Jim's point is there's only one 5 here, yet there's two 5s in these two columns. And therefore, there's a second 5 in those two columns in one of these places, but it doesn't go in a whisper. So in fact, we have a corner marked 5 here, which rules a 5 out of those. So we do have that. Was Josh's point originally? Thank you, Josh. Is it possible that this is a region, or does that break in some way? I'm trying to mentally fill it in my head. If that was a region, then this would, of course, be a region. This would, of course, be a region. This would, of course, be a region. That would be a region. This would be a region. And that would be a region. It looks to me like it works. I was wondering if there was some sort of parody thingy going on with that I couldn't have two things offset like that. But it looked to me like I don't understand this the same difference business. The people are like, why can't this be 1, 2, 3? Do I not understand what a same difference is? Each pair of adjacent digits have the same difference. The difference value can be different for different lines. Oh, it's because right or okay, got it. Okay, sorry. I had not appreciated that these two were the same. So if this was 7, 3, then both of these have to be. Oh, 3 was not a good choice, was it? Wait, no. Yeah, both of these would have to be 5. So the point is, yeah. So either these two are. So if these two are different, these two are the same, is the point. Otherwise, these two are the same. And so the point is there can't possibly be a border between these because there's two worlds. Either these two are the same or these two are the same. Yeah, I had just not appreciated that these were over the same cells, which chat had appreciated. So we get that going on. Oh, sorry, other way around. Sorry, there definitely is a border. Right. Sorry. I proved that there was a repeated digit there, and then did the wrong thing. Okay, so sorry. So we in fact get that, like that. Okay. I was close. Isn't just a couple letters off. So yeah, so these are the two that aren't on the whisper line. And I know there's at least two high digits and at least two low digits in the puzzle, but that doesn't necessarily mean there have to be an additional high or an additional low on the RENBAN. It does not have to be the case. This now either goes up or down, because it can't go left or right. It is boxed in. Let's see. This is a parity line, this red thing. So these two have the same parity for whatever that is worth. Uh, 5. That's true. So Jay Dyer's point is either this is a region, or so either this is a region or this is a region. If this is a region, then now we've got to go, all 5 of these have to be different. That just doesn't work, does it? There's no way that works. Oh no, it would work if, in fact, I think it's true that if these two are in the same region, I think that forces this to be no, that just doesn't work at all. No, that's just completely impossible. If these two are in the same region, I can't have repeats in these 5, which means this starts somewhere and then goes up or down by that amount, that many times, 4 total times. But now it's got to go that amount again. But now I have to connect back. And so the difference between these two cells going one way is different than it going the other way. So that's a problem. So in fact, although I don't think I articulated that particularly well, I can't make these two be in the same region, which means I have to make these two be in the same region. And now, by the same argument, I can't make these two be in the same region, or I would do exactly the same thing. So I have to separate those. And once I do that, then that forces that, like that. So we've got all of that stuff going on. And so now these 5 cells, so these 5 cells can't have repeated digits? No, I think those two have to, no, those two can't be the same. I feel like there's still something smart for me to say about this, this same difference line, but I can't figure out what the smart thing for me to say about it is. Okay, well, there is a max and a min digit on this line is a good way to phrase it. And the max and min digit on the line, whatever they are, can't go in a place where the two cells see each other sudokulogically. So the max and min can only possibly go in these cells, but the max and min have to go across from each other, I think. Otherwise, you have a problem. So I think these are the max and min digits of this thing, right? And then we've got to read the same direction, same going this way as we do going this way. So I think these are the max and min, and then I think let's choose a different color. I think these two are the same digit, and these two are the same digit. Oh, and this is the same digit. Sorry, we can use the little red thing. Maybe that's a little unclear. We'll go into purple circle. Okay. So, and do I know all of these are different? So at least those three are different. Is there any way blue X and purple circle are the same? It's possible that blue X and purple circle are the same, I think, as best I can tell. Yeah, I think that's possible. Uh, hmm. Oh, blue O and red O can also be the same. That's true. So I have to be very careful with this sort of marking that we don't sort of interpret this. Uh, so Jim is asking what the difference can be now. If the difference was 2, say, then as I started here, I would go up by 2, 4, 6, 8. So the only way the difference is 2 is if 1 and 9 are these, and then these are 3, 5, 7. Which would force all the odd digits to be in the puzzle. I'm trying to see if that somehow breaks this parity line. Not that I can quite see. So the difference is not larger than 2. If the difference is 2, then this is 1, 3, 5, 7, 9, which seems suspicious with this, but I don't quite see how it breaks immediately. Otherwise, this is basically a RENBAN. I mean, it just is a length 5 RENBAN. Is that a problem? I mean, this is even stronger than a RENBAN. It's like a RENBAN-bometer or whatever. But I don't quite see what to do with that. Ah, the red X's. Thank you, Selena. It would have taken me a while to see that. These can't be connected because if these two are connected, then that region doesn't have red X in it. Thank you, Selena. So in fact, that forces this region. So now this up here is now forced to do that. This over here is forced to do that. And now we have all of our regions.
Very nice.
I like that. Oh, that's right. Tristan is here.
Sorry, I was so monumentally distracted by the things that, again, apologies to Marty.
Let's see. Okay. The next step is the fun one. Okay, so these three have the same sum as these three.
I'm
Tristan,
super
you're
loud.
apparently super loud.
Let me have a look.
Okay, so
Check.
I really want to break these are 1, 3, 5, 7, 9, but I'm kind of getting afraid that these are 1, 3, 5, 7, 9. So maybe I'm supposed to actually break the other way, but I'm trying to think how I would go about doing that. This 5 up here feels like it's supposed to be significant. But I don't think that it can be immediately.
There we go. All right. Sorry about the loud.
Yeah, and I know basically nothing about these because of the region sum line. These two definitely have the same parity, and it's the same parity as that. Oh, right. 5 in row 2 is in here, points out J. Dyer, just because of sort of claiming. So one of these cells is a 5. So, oops. So therefore, these aren't 5. So the 5's actually down here. Uh, uh,
We can reopen the bet tree because of all the crazy stuff that went on. So anybody who wants to make a few more bets, you can do.
So J40's point is that if I look at the first 2 rows, then these highlighted cells are a set of the digits that are in the puzzle. And therefore, because this box is a set of the digits that are in the puzzle, these cells are the same as these cells up here. So these 2 groups of cells are the same cells. And we get a bunch of similar stuff like that throughout the grid, I believe.
Yep. Nikolai asked if it reset existing bets. It did not.
So I don't quite see what that does other than, again, force the 5 down here again. But we've got the other 4, 6 is with 5 at the top right.
Yep.
I don't understand. What other 4, 6?
The 4, 6 that isn't on the German Whispers.
So the claim is there's nowhere else I can put a 4, 6 on this line because I can't put it there, or there. Right. Okay. So yeah. So
in these
so this box needs both 4 and 6. And so apparently, although I did not see this, Garian said that you can put one of them here, but the other one has to go up here, making this.
Wait, do we know that there are both 4 and 6 in this puzzle?
Yes, because of the length 6 RENBAN.
Right.
Genius. Okay. So this is 13579, as pointed out by J40, because these digits are these digits. And so therefore these 2 digits can't be consecutive. So that is very cool. So remember, this yellow line is a NABNER line. So none of these digits are consecutive. And so therefore these 2 digits in particular aren't consecutive. And so we know that these are 1, 9, these are 3, 7, and these are 3, 7, and these are both 5. And we get our 5 dance. Boop, boop, ba-doop. Whoa. Ba-doop, ba-doop. Wah. Ba-doop, ba-doop. Wee. Thank you, Zach. Thank you. Okay, I'm glad I did not spend more time trying to prove this isn't what happened. I suddenly became suspicious that I was not trying to prove that this doesn't happen. So that places the 5 up here, by the way. Okay. We now... okay, so there's no 3, 7 as the odds here. For what it is worth. I already placed the 5 in row 3. Oh, row 4. Row 4's 5 goes here. I agree. Yeah, so every odd appears in the puzzle. I feel like that's supposed to tell me what's happening here, but Oh, I know X isn't 5. Okay, so if these X's are odd, they're a 1 9. So if these cells all see 3 7 and 5. So if these are odd, they're a 1 9 pair. I still don't see why that's broken, and so it's probably true. But that's the only way that this will work. 5 in row 6 is placed. 5 in row 6 is placed. Very nice, the cogito. The only place for 5 in row 6 is here. Let's see. And so now 5 in this region is here. 5 up here is there. And now 5 is here on the NABNER. This cell's definitely even. I agree with Jay Dyer about that because it does see all 5 of these rather beautifully. Let's see. I don't think I know what's going on with that yet. I'm trying to decide. Because remember, we know that either those are both 1 or 9 or those are both 1 or 9. I'm trying to see if any of that sees anything that would break with this over here. But I don't quite see it yet. Tall Cat makes a donation. Forget a new mouse for Tristan. Buy Zach some decent fish for Christmas. Let us get a dance, and Zach will be very happy to dance for that. Boop 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 boop. Woohoo! Woohoo! Thank you so much, Tall Cat. Greatly appreciated.
Thanks so much.
Thank you, Zach, as well. Thank you for the generosity, everyone. I'm going to use the cogito's point that the 4 and 6 in this box are definitely over here because they're not on the NABNER with a 5. You fly out to England in 7 hours? Well, enjoy England. So that's a good spot from Garion. We need a 7 along this line somewhere. And in fact, the 7 can only go in one of these 2 cells because I can't put the 7 next to a 3, 4, 6, or 8. And so the 7 is in one of these 2 cells. And so these are from 1 to 7 for sure. Now, putting the 7 here would make these a 1-2 pair. Is that a problem? Don't know yet. That does put 2 in the puzzle regardless. That's true because the 7 definitely is in a spot where it's going to be next to both 1 and 2. And so we've got 1, 3, 5, 7. Let me just write out the digits that we have in a cell. I'm just going to write it down here. We know we have 1, 3, 5, 7, 9. We've got 4 and 6. And we've just argued we've got 2. Is that 8 digits? That is 8 digits. So in fact, there's no 8. So 8 is the missing digit. Poor 8. So these are 3, 6. Which means the 1 doesn't go over here because the 6 is going to eat up the 1. So these are 2, 7. And so one of these 2 is a 1. And so the 9 in this box now has to go in one of these 2 cells because it no longer is allowed on the RENBAN. And so that forces onto the RENBAN, now that I can't have 8, I've got at least 7, 6, 5, 4, 3, and 2 have to go on the RENBAN now. Yeah, 3 and 2 now have to go on the RENBAN. So these digits on the outer flanges are from 1, 7, and 9 only, because of that. So we've got that. That 3, 6 pair has made this a 4. Agree. Means that there is a 4 in one of these cells, so none of these are 4, and that's not 4. So now the 4 is in one of these two cells only. Let's see.
Zeta, you're not allowed to actually solve this puzzle because currently the puzzle has 69 solves.
Oh no, I'll have to be very careful. So the 2
You just have 1 and
can
9
only
left in
go
that box.
next to oh, we're doing that's so much more boring than the way I was gonna do it. I was gonna say what the 2 had to go next to, and then say the 2 could only go next to a 9, and so fill this in. But that does work. I will admit with some reticence. So there's a 1 in one of these, so there's no 1 on this thing. So there's a 1 in one of these cells, which starts to feel like it needs to work. Right. So Jay Dyer points out that actually I can still use what I was going to say, because the 3 can't go next to an 8 anymore because there's no 8. So in fact, these cells are both 1, 9 regardless. So there's not a 9 on here either. So the other 1, 9 is in one of these cells. There's no 1 or 9 on this white dot. And there's there could be this cannot be 3, 6. Because if this was 3, 6, it would put the purple 1, 9 there, but the purple 1, 9's already there. So this dot is not 3, 6, and it doesn't have a 1, and it doesn't have an 8, so it's only 2, 4. Is the only black dot that is left, given that the black dot sees that 1, 9 pair, can't be 3, 6 because that cell can't be purple 1, 9, and 8 is not in here. Okay, so we've got that now as being 2, 4. And so now we know what the even digit in these two cells is, because it's not 2 or 4 and it's not 8, so it's a 6.
That 2, 4 resolves the whole whisper.
2, 4 is right, because this can't be 4, because 4 would do that.
Well, it doesn't matter. It's low.
I liked my 6 deduction, but anyway, this can't be 4, as Tristan points out, because it would require putting 13 9s in places where you can't do that. So that's 2 and that's 4. So that's 1 and that's 1 and that's 3 and 2, 9 and 9, 7 and 6. Also, people have pointed out that 2 and 4 are both low digits, as it would happen. So that is 1 and 9, 3 and 3, 7 and 7.
7 is the last thing on the whisper.
Add it. Let's clean up. Clean up some over there. So that is a 7 because it can't be a 6 or an 8. So this has become a 1 through magic. So we've got all of that. So now the 9 in the box has to go up here, because otherwise we have problems. So these two are the same digit for whatever that is worth. So we've got some 3s. That's not a 2 or a 6.
Nice, Jay.
So we know this digit is odd, and it's certainly not 1 or 5. or 7. So this is either 3 or 9 are the only options for this cell. I know it's odd because the last even in the box is down here.
J. Dyer has the coloring of the parity line because blue X sees all odd digits.
Okay. So blue X sees 7 and 3. It sees 1. It sees 9.
And 5 in the column.
And 5.
Or
yep.
the box.
Okay, yep. So this is indeed even. So indeed that's the 6. Well spotted, Jay. So these are 2 or 4. And that one is not a 4, so it is a 2. These are odd. So this one is only 9. It sees every other odd digit. This one is 1 or 3. I don't know which one yet.
That's
a 2 because of the palindrome. Yep, palindroming away. I should just mark these cells. There's no 8 in the
4.
puzzle. So this is a 4, yep. Making that a 4 and making that a 7. No 4 goes over there. These digits don't include an 8, so that is a 6 and a 1-3 pair. That 1-3 goes here in this box because it needs to go somewhere. So 1, 2, 3, 4, 5. This is a 6. So now in the column, this is a 3.
And a 2 at the beginning of row 7.
2 at the beginning of row 7. Yep. Speaking of 2, the 2 goes over here in one of these cells. So these are not 2. Oh, but there's an extra 2 in these 2 rows. Where's the other 2 in these 2 rows? It's only here. And that's, again, if you want to think about it this way, that is using the fact that we know these are a set of the digits 1 through 9 except for 8. So what am I missing? I am missing, well, I've got the 2, 3, 4, 5. We need a 6, 7, 8, and what am I missing? I skipped a digit. 1, 2. Oh, it's 3. 3 is the other digit. 3 is the other digit. And that is the 3 and the 6. So no 6 there, no 2 there. That 2 gives me a 2 there by the same difference line.
By the way, I think if this is a 9, then the region sum is too big.
So let's see. These are a 1 and a 7. So again, these I should know are a 4-6 pair because there's nowhere else for 4 and 6 to go. And so I should know what this is. 1, 2, 3, 4, 5, 6, 7. It's a 9, which makes that a 3. Sorry, Tristan.
I like my way better.
I don't have to max. Fortunately, I don't have to now think about it. Your way, I had thought about before and wanted to avoid if I could, because I didn't want to do the math to figure this out.
Okay, see, those
these
aren't 1, 2, 6.
12.
Oh, they don't. They. Right. They don't have a 1 on them.
Yeah, there's no 1 in them. So let's see. Maybe I should just mark up this box and just say, okay, well, that's a 4 and a 6 and a 9 and a 2. Okay, so the region sum line was completely irrelevant for purposes. It was only useful for region building and nothing else, I think, because it was all filled in automatically. So there is a 7 and a 4. There is a 6. 1, 2, 3, 4, 5, 6, 7, 8, and 9 is the bet tree. Congratulations to all the 9 bettors out there.
Funny thing is, I forgot to ever close betting.
True. Congratulations to the 9 bettors. That was lovely. I really enjoyed that.
That was very nice. And again, apologies to Marty for...
sorry for ruining your puzzle. But that was quite a delight. I enjoyed that. I like this. I like this sort of variation on chaos construction. I think this is cool. I bet you could do a version of this where you you sort of delay the gratification a little bit more of how exactly these regions sort of fall into place. But that was very cool. I enjoyed playing with my dominoes a lot.
Yes, very nice. It's going to be Nell Gwynn's puzzle up next.
Alrighty. Let me dig up Nell's puzzle, if I can find it. It's in here somewhere, maybe, possibly. Maybe not. There we go. I have found it. But we're going to take a short break before we do Nell's puzzle.
Sure thing.
But we will be back shortly. Did you pay out the bets, by the way?
I did.
Okay, excellent. All right, we will be back in just a moment.
All right. See you shortly. We are back.
Welcome back, everyone.
We have Nell Gwynn's puzzle here. Here we're going to have you bet on the absolute value of the cell. So if you bet 2, that will pay out for -2 as well.
So just so that people actually have any idea what's going on, maybe we should say the rules.
That's true.
Is that we aren't using the digits 1 through 9. Instead, we're using the digits -4 through 4, which, funnily enough, is exactly what someone did in one of the more memorable puzzles from the 5 list challenge, which was, I think, the first setting challenge, if I recall correctly.
I believe so.
There was a puzzle called Fire and Ice or something like that in there, which had a very similar use -4 through +4 sort of energy. So then we have between or doubles. Each line with circles on the end is either a between line or a double arrow, but not both. So we have our ambiguous one of these.
2 of them.
Yeah, and then we have region sum lines, which are saying that these digits sum to the same thing as that, and these digits, and I guess I shouldn't really call them digits, these numbers sum to that number.
They're digits.
And sum to that, and that. -4 is not a digit.
Says the mathematician.
I mean, it simply isn't a digit. Uh, uh, we have zipper lines. So each pair of numbers equidistant from the center sum to the number at the center. So if this number is a 4, these two numbers sum to 4.
I've been wanting to play more zipper line puzzles.
Uh, I've been looking forward to the even length zipper line puzzles that are inevitable.
By the way,
I
Zeta,
saw some people talking about them.
have you been able to see my annotations?
No. That I can see for half a second. It flashed on the screen and then disappeared. But that is more than I have seen any of the others. And then this is a 10 line. Gray lines must be divided into non-overlapping groups of numbers that sum to 10. I wonder if I'm allowed to do if I'm allowed to deduce that 0 can't be on the border between two things because it wouldn't be unique. I'm not sure if that is a valid deduction or not. But anyway, we have that. And so with that, we can get on. As Eckbert says, in this puzzle, the secret is 0. Because the sum of all the digits in the grid is equal to 0, which is hilarious.
That's funny.
CTC had an even length zipper line the other day. Yeah, it's possible the entire line sums to 10. That's also something I've thought about with this is that we could do that. Mostly I'm just curious if part of solving the puzzle uniquely is deciding what the 10 sums are, because it's not actually sort of in the rules that you have to decide what the 10 sums are. All it says is that that it has to be possible to divide them. Actually, sorry, it does say must be divided into. Basically, I'm just very curious about whether I need to decide which side the 0 goes on as part of it, or if this puzzle has just been rigged so that didn't come up. Okay, so
we do.
So these are certainly from 1 to 4, and there's certainly a 2 on them, but it could be a +2 or a -2. Although it's probably not a -2 because this line needs to sum to 10 actually, right? So actually this has to be 1, 2, 3, 4 with no 2, and these are all positive. And so positive are going to be orange because hot is high, I guess, traditionally.
Oh, that's cute.
Oh, they are. Oh, yeah. Okay. The 10 line there is like the Zeta and the channel logo. That's very cute. Yeah, 0 gets to be green, of course. I don't think this could possibly be 0 though. Oh, sorry. Maybe it could be 0 if it's a double arrow. Okay, so then we've got but the point is the maximum 4 things sum to 10, so I can't break this up, was the point of this. Yeah, all of this is 0 or negative, which is, I guess, very interesting for the purposes of the 10 line. So I'm going to actually mark that this is 0 or negative. Because my sum up until this point is
definitely negative.
Definitely negative, yes. So
the question is
and now actually, because I can't use a 2 on these, that actually means that these numbers are all at most +1. Because I need to use an even, and I'm not allowed to use 2 because the +2 is down here.
So I wonder if this is going to have to be a double arrow.
1. And so this one in particular, because these 3 are at most +1, this one has to be 0 or negative for sure. Because of that. And that means that, yes, so this cell is at most positive 1. And so the question is, if this is at most positive 1 and this is at minimum minus 4, how many digits are there
No,
between
no.
minus
Oh, never mind.
4 and positive 1? Minus 3, minus 2, minus 1, 0 exactly is the it would work, although
Oh,
in that
sorry, I didn't start the
version
betting.
Something
So you bet on the absolute value of the cell and bet other for 0.
Okay. Every time I see someone type in the bet interface, I always think they're betting that the outcome will be 22. But because I would say it the other way. I would say bet 40 on 8, not bet on 8 with 40, which is linguistically awkward, but is the way it works.
Yep. Nothing I can do about that.
Yep. Let's see. Oh, okay. Garion says that if I make this all negative, that sums to minus 10, and then this would sum to at most plus 10. And then I can't even get to plus 10. So that's a good point. So Garion's point is one of these is 0. Because if these are all blue, then they sum to minus 10. These would sum to at most 10. That would mean up to this point, I would be at most 0. At most 0, and then these 3 just can't get to 10. So therefore, that's never 0. This cell is legitimately negative.
Yep.
So we've got that.
And yeah, those 3 cells can't even all be positive in box 5 because of the column.
Right, that's true. Yeah, these can't all be positive. Because we've already got 2 of our positives down here. So we've got a maximum of 2, 3 positives. And then 4, 5, 6. So we have a maximum of 6 positives. And those 6 positives sum to a maximum of 18. So if I make every cell that can possibly be positive on this line positive, keeping in mind that I can only make 2 of these positive, the absolute maximum I can get to is 18, which means the long 10 line needs to have at most 8 worth of negatives on it. So if it needs to have at most 8, that means this can't even be a 1. This is a minus 2, 3, or 4. So Paul Fly says that we can't even get to 3 positives in this box. Why can't we get to 3 positives in box 5?
Oh, it's the top. The top. Oh, no. Never mind. Never mind. I think that's not a true thing.
But let's see. And so
Oh, Paul Fly just didn't see row 6, column 6.
J Dyer, I'm making 2 of these cells positive in my maximization, not all 3 of them positive. So in my maximization, 2 of these are positive, and that's positive, and then these are positive.
Yeah, so they'd be 2, 3, 4, 2, 3, 4.
So in the absolute maximum, the positive numbers on this line sum to 18. a 0 and a zipper dot would be very cute.
That would be very
Uh,
satisfying.
so we've got at least one negative or 0 here. Uh, so yeah, this sums to at least so if I sum the negatives, the negatives here sum to at least -6, and then -7, counting the one in this column. So the negatives, even if I minimize them, sum to -7 at the minimum, which is one away from the 18. That certainly means we have a 0 in this column. Yeah, and so the question is, can I possibly add any more negatives? And so if I put a second negative here, that definitely eats more than 1 degree of freedom. Ditto here. Here would be a catastrophe if I made this another negative. And so the question is, can I get away with a negative here? And the answer is no, because remember in sort of our 18, one of these is a 2. So if I make one of these 0 or a negative, that eats alive one of these. So the point is all of these do have to be positive, because remember, in our 18 sum, we're using 2, 3, 4 as our positives in every spot that we can. And so these could be 1, 3, 4, for example. But that is that. And so these cells are green or blue as well. And so, yeah, as Paul Fly says, maybe the easier way to see it is if you take away a positive, then your maximum is now 16.
Now,
and then, et cetera, et cetera.
now that can't
but
be
I know
between
these
line.
aren't 0. Because we noted, remember, that you needed a 0 in here. If you didn't have a 0 in here, instead of summing to -1 at sort of best case, they now sum to -3 at best case, and that's 2 degrees of freedom. So these are actually negative. So now, yes, so now this is definitely, as Tristan says, a double arrow. So I don't think this can be 0 anymore either, but I'm not 100% sure about that. I agree with 99% Sneaky. I was just looking at this. This is either positive or 0. It's certainly not negative. Okay. I'm looking at this string of stuff. Let's see. Paul Fly says this can't be 2. Because if this is 2 -1 0 +1, I don't quite see why.
Well, that would be a negative too. So
this is negative or 0. I agree with that assessment. Oh, it's because if this is -2, then this box now, its negatives now sum to -9, and I can't have them sum to, sorry, sum to -8, -8. But then remember, there's another negative here, and then I'm getting at least -9, and I can't get -9. So this can't be a 2 because of the what it would do to the sum. Okay. I'm pretty sure this can't be a 1, but maybe it could be. If this was a 1, it would have to go 1, 0, 1, I think. Let's see. Oh, that's true. We
We have a
do
positive
have
quad.
we have a positive quad, so everything else here is negative or 0. Just for the record. Okay. And so I can say something interesting about where the positives go in this column, because the remaining 3 positives. Oh, sorry. One of the positives goes here. But that's not actually that interesting. I thought it was going to be more interesting than it turned out to be, actually. Let's see. Okay, so Josh is pointing out we can do exactly the same thing we did with Paul Fly down there, where we can sort of ask ourselves, what happens if I pull off 0, 1, or 2? If I pull off a 2 here, that eats exactly one of those things. I didn't say it couldn't be positive, Paul Fly. Or sorry, Jim. I think it could be positive. I was thinking I was going to force it to be positive because of this, but I don't think I quite can. I was noting I knew these couldn't both be positive, and I thought that was going to do something, but I already knew those couldn't both be positive.
Oh, that's true. Oh, is that going to place a 3?
Sayori points out that one of these is a 3, so there's no 3 up here. And so now this is going to have to be a 3, isn't it? Because if this is not a 3, then we get to at most 7.
Too many
Oh, no,
degrees
7
of...
is still okay. We can do 7, right? No, 7 plus 9 would be 16, because that would be 7 plus 9 would be 16, and we know our negatives sum to at least -7. And so 16 is too small. So we do need a 3 here. And we get to do our +3 dance. Ba-boop, ba-doop, woo! Ba-doop, ba-doop, wah! Ba-doop, ba-doop, wee! Ba-doop, ba-doop, wah! Ba-doop, 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 wah! Wee! Thank you, Zach. Thank you.
Nick down.
Okay. And so assuredly now we have a +3 in here.
That's true. It does take 4 off of the white dot.
It does take 4 off of the white dot, or add 7 to it. You can choose. If this is negative, 99%
That's too many negatives.
Out, that puts 2 honest negatives on here, whereas in our minimum we're only putting 0 and 1.
Well, it also puts too many negatives in the column.
Yes, that would also make 5 negatives in the column. That's much easier than my proof. So this is 0 or positive.
We need a 4 in row 2, column 5, points out Nicholas.
Yes, that's true.
We cannot survive without a 4 there.
Yeah. If we couldn't survive without a 3, we definitely can't survive without a 4. So those are a 1, 3. So these are a 2, 4. So the
and that 2, 4 gives us a 3 in the box. Row 7, column 4. Can't be
no,
4.
no.
Oh,
That's not how
God.
this puzzle works. Nice try, but sadly, not how.
But the 1, 3
how-
pair legitimately looks up.
Yes, the 1, 3 pair does legitimately look up and make this a 2, which then makes this a 1, actually. So this is no longer 0. So now there's a 0 in this row. This is a 2 or a 4 now. Oops.
Are we going to need a 4 in that cell to get high enough? Does a 2 eat too many degrees of freedom? Because you can't put a +4 over in column 4.
Right. So yeah. So if you make this a 2, then your maximum in this box is +6, which would be +15, which is nowhere near enough. So yeah, that definitely has to be a 4. I concur with that statement. It's 1, 3, 4, 2, 3, 4. Oh, but this box can't be 2, 3, 4 anymore. That's the point.
And
so this box.
There goes our degree of freedom.
So as Paul Fly says, there goes our degree of freedom. Right. It can't be 2, 3, 4 because I can no longer put a 2. So it's got to be 1, 3, 4, which means that our numbers on this line that are positive do in fact sum to 17. So I only get 7 worth of negatives. I already get at least 6 worth of negatives here, but I can't anymore get 7 worth of negatives here because I am getting a negative, at least -1 here. So therefore that's a 4. And we've got that. And the negatives in this column do have to be, well, the quote-unquote negatives have to be just a 0 and a -1. So that means that these are a 2, 3 negative because we've used the -4 and we've used the 0 and the 1 in this column. But 3 is already too big because if this is 3, I mean, too big in the negative direction. If this is a 3, that would be a -2. I can't do that. So in fact, that's a 2 and that's a 3. And now it has to be the case that this is the -1 and this is the 0. And these are the 2 positive ones. -1, 0. This is for
and
sure
those
negative.
positive ones are 1 and 3.
With -1. This is for sure negative. These are 1 and 3. I agree. These aren't green anymore because reasons. If that were 0, that would be 1.
That's -2.
Oh, this could be 0. Sorry, this could be 0. It's 1. Good point.
0 or 2.
Yeah, it's 0 or 2. Right. The 0 in box 2 looks at it.
Yep.
So it is indeed 2. So these 3 cells sum to -4. You could just basically cancel these out of the double arrow now and say that these 3 cells sum to -4. This is now a 4 only because of Sudoku. And so now I need these to sum to -4.
So they're going to need a -3.
So I need a -1, a -3, and a 0.
Yep.
So that's the only way to do it because that's now the absolute minimum. And of course, this one's not the 0. So everything else in the column is positive. There's no better way to do it. So this is a 1 or a 2. Uh, these both being positive.
So those are minimum.
Does that mean I can't put a negative on here? Because if
Well,
I
those
put a
two
negative on
add to
here, it's at
minimum
least
4.
-2. And so I can't get to, because as Tristan says, these add to a minimum of 4. If I put a negative on here, it would be at least a -2 because 0 and 1 are gone. And -2 plus 3 is nowhere near big enough. So these both have to be positive.
And they definitely have to include a 2.
Why?
By the row.
By the row. I don't understand.
Row 6.
Oh, sorry, you're right. Sorry, we just now have. Sorry, the thing you're actually saying is we have a quad. Is what you're actually telling me. So
Sure.
all of those are negative or 0, and contain a 2. Okay.
So that means the other 2 on that region sum line are also negative or 0.
Can I not put a 1 and a -4?
Ooh,
Obviously not in that order. But 1, -4
yeah.
would work with 0, -1, -2. We had to be very careful about that over here. It's probably eventually going to turn out to be true. This cell, by the way, is negative or 0, just for the record. These two sum to 1. And so they need to have a negative and a positive.
Somebody made a good point. Screaming Ice Cube made a good point. Is that if row 6, column 4 is 3, it makes the sum of that region sum line 3, but that can't work by column 3.
Let me do my point first, and then we can try and figure this out. Because these two sum to 1. And therefore, they definitely can't involve a 0 because there's already a 1 there. And so they have to involve a positive and a negative, and the only thing they can involve is a +3 and a -2. Because we can't do +4 and -3. So these are a +3 and a -2 over here. Okay. Now, you were saying something about something being 3?
Yeah, if row 6, column 4 is 3, this is Screaming Ice Cube's point. That makes the region sum line on the left add to 3, but that doesn't work in column 3. So if that's a 3, the region sum line breaks.
So you're really just saying there can't be a 1 on here. Because, yeah, you're just saying there can't be a 1 here is what you're saying. Because if there's a 1 here, then these are 1 and 2. Because we already know there's a 2 there. And then we need to make these sum to 3, but we can't because we don't have a 0 available. I agree with that. So these need to sum to 5, which does indeed make this a 1 and that a 3. And so these are 2, 3, or 1, 4, one of those. So whatever they are, this isn't a 1 or a 2. This is a 3 or a 4 because we've got a sort of virtual 1-2 pair there.
Eckbert with a good point is that row 3, column 6, if it were -4, we have too many digits to sum in box 3 to make that -4.
Because if I take the sum of 6 digits, the most negative that it could possibly be, and keeping in mind I can't use the -2, so the most negative this could possibly be is -1 -3 -4 is -8, 0, and then 1 and 2 is -5 is the most negative that this could be.
So it actually doesn't.
If this was -4, then there would be a -3 on this. No, I'm not quite sure. I don't think it quite works
You
yet.
might have to look at how it interacts with the line in box 6. Because we only
Yeah,
have.
that we'd have to make -4 in two different ways, which would have to be uh 0, 4, and a -1, -3,
But that's too
which would,
many
I think,
negatives
put
in the
way too
box.
many non-positive digits in this box. Uh, so let me convince myself that the only ways to get to -4 and 2, right? The only way to get to -4 and 2 is to add two numbers which are both negative or zero. If you include any positive number in your sum, then you can't get to -4, and that would be 7 negative or zero numbers. So this can't be -4. So it is zero. And that's 4. I think I proved that in a completely different way than was desired, but I liked the way that we eventually found an elegant proof of this. So this now must be a positive 1, because it's the only thing left in the row that is consecutive with 0. These are a 1, 2. Funnily enough, these we know what they are. They are a +2 and a -4. So +2 and -4 annoyingly sum to -2. Uh, oh, but it would be both. It would be both. So it can't be. So this, so yeah, so +2 and -4. If I were those two, this would be both a between line and a double arrow, and it can't be. So that's
So that
got to
one
be a
is
1 and a
definitely
2.
1, and it's a between line.
Yep. So this is not a 1 anymore. Oh, this one's not a 3 anymore. So that one is a 1. Speaking of things, oops. Speaking of things that aren't things. Okay. If this is a 0, these sum to -8. And then I need to make -8 and 2, which I cannot do. So this can't be the 0 by looking at row 6. Sorry, I'm not looking at J Dyer's point. I promise I'll look at it next. But this being a 0 would just by the magic rule make these sum to -8, which I just can't do in 2. So this is a 3 and that's a 0. So that is a 0. That is not. Okay, so
Yeah, we can math
J Dyer
out.
wants us to write out what these are, because we've got a 2, 3 of everything in this row.
So there's 0,
So
1,
those
4.
just cancel to add to 0. Plus, so the only things left are 0, 1, and 4, right? So this is 0, 1, or 4. But we know that these sum to 0,
so
and
those
these sum
also.
to 1. And so that needs to be a -1 in order to make the sum work.
Yep.
I
was about to say that. If we look at the remainder of column 6, we can math out what row 7, column 5 has to be.
These are 0, 4 now, by the way, just for the row. 0 and +4. Sorry, what were you saying? Oh, we now know what the sum of these two is?
No,
what is it?
6.
It's now -5 is what these need to sum to. I can't get to -5 with a positive number, and I can't get there with a 0 either. So these are both negative, and they, by that 1, have to be 2, 3 as my negatives in order to get to -5.
That's true.
I agree with that.
So we know what's left in column 6.
Yeah.
In box 8.
It's already marked.
In box 8.
Oh, I see. In box 8, I see.
Those are all negative.
Right.
And we know what they are.
This is my 0, is what you're saying. Yep, agree. Okay.
Oh, that's true. Martin points out that row 5, column 8 and 9 have to sum to +5 to make up for the region sum line.
Row 5, column 8 and 9. That's true. So these sum to 5. Sorry, minus 5 total. So these need to sum to +5, and the only way for them to sum to +5 is for them to both be positive and for them to be 1, 4. And now each of these is a positive negative pair of the same digit.
Yep.
So these are a positive negative pair that's not of 1, 3, or 4. So this is a 2, 2 pair, which makes that a 4 and that a 2. And that 4 is negative and that 2 is positive. And now these are a 3, 3 pair. And we know which 3 this is. This is the positive 3 and that's the negative 3. Oh, and actually this 2, 3 pair looks up and tells me that's the positive 2 and that's the negative 2.
Now we can finish row 5.
So row 5 and 4 have in them, let's see, let's do this one first. So
okay.
We've got a positive
1 and 4.
And a negative 4. Sorry, no, a positive 1 and a positive 4. Right. And these are both negative. Okay.
Surely the dot of the zipper line can't be 4.
It can't be, because this is negative, and so these two can't possibly sum to 4. So that's a 1 and that's a 1 and that's a 4. And now this is negative, so this has to be positive. Otherwise, I'm not making this work. And that's a 4, so this is just a -3.
Yep.
In order to make those work. Let's see. And this number is these are a 2, 4. And that can't be a 4, because if that was a -4, I would need that to be a +5. So that's a 2, and that's a 4, and that's a 3.
Yep.
And that 3 looks down and makes that not that. A 2 and a 3. That 4 is looking up at this cell, which is no longer a -4. So it is now the 0. And that is, and that is the +4 for the row.
Todd points out the double 3s in column 7 lookup.
Yep. This needs, one of these is a +3 and one of them's a -2, and we know which is which. So that is the negative and the positive, -2, +3 to make the region sum line work. Very nice. Okay.
Oh, -3 by Sudoku.
-3 in box 3, because we've got a -2, -3 pair looking up over there. So this is -3 by Sudoku, Sayori points out. This cell sees every negative digit in 0, so it's definitely positive.
It's a
+1,
positive
2,
4.
3 in the column and 4 there.
It's
a 4. It's a +4. Let's see. Do we have any similarly deposed digits? Yes, this sees every... Oh, but I don't know if this one's 0 or not, unfortunately. This is -4 or 0, I think.
And +3 in the column goes just at the bottom. Column 9.
I'll do that for Nicholas. +3 in the column does indeed go here.
Points out Garian.
Agree. Which makes a 4 go there, which makes these a repeated 2, 3 going there. Sorts out my 2 and 4 there.
Your 1, 3 is also sorted out.
Yes, my 1, 3 is also sorted out. Very good. So now these are negative or 0, and those are negative or 0.
And 0 is actually 0 is placed in column
0.
So neither is the other one on the zipper line, because zipper line math.
Right. You can't put a 0 on a zipper line except in the center. And so you can't put a 0 on a zipper line except in the center. So you have to put the 0 here, is
and
Tristan's point. And so this is positive, and we know that it can only be +1 because it can't be 2, 3, or 4. So that's a 1 and that's a 1.
Where does it see
that's not a 1.
Oh, wait.
The box, because these need to be the same digit in order to add to 0, and the 2 and 3 are gone in the box, and the 4 is gone from the row.
Right.
And so
0 is placed in
this
box
is
7.
negative because it sees all the positives in the row and the 0 in the box. That is 0. I agree. That 3 looks over and sorts out that 2 and that 3. This is negative by magic. Let's see. Over here. This is just a 4, just by Sudoku, and these are positive, and are a 2 and a 4, and we know the order.
Jim points out
over there.
-1, and well, there's just tons of Sudoku.
Yeah, so this column now needs a negative, and so that's the -1 and the -4 for the column. This column has all of its negatives, so this is actually the 0. This is not negative anymore. It's actually a 4. This column still needs a 0, so that's a 0. This box still needs an orange 2, which makes that an orange 1, going over there.
I kind of suspect the mark button wouldn't be very successful in this puzzle.
I suspect that as well. The orange 1 is placed in this box here by Sudoku. So this is blue. And so we've got all of that.
It'll help if you note the -1.
Where does the -4 have to go in this box? If I put it anywhere other than with the +1, then it's going to make a total that's smaller than the other total could possibly be. So the -4 has to go there, making the total -3, which works with my 2 and my 1, of course. That 2 looks over and makes that a 3. That makes that a 2 and a 1, makes that a 3 and a 2. And so this is a naked -1. Making this a +2. Lovely puzzle, Nell. Sorry you could only be here for half of it, but very nice, very cool sort of logic. Even down to just like the break-in being, oh well, this length 4 10 line, which would normally be the most useless kind of 10 line, is actually super useful because it's completely forced. Good. Well, hopefully you enjoyed the solve. Hopefully we went relatively the same direction as you intended with the various steps.
Sorry,
go on.
Well, what I think will probably take the rest of the stream is the Cogito's puzzle.
Seems likely. But shall we take a break before then?
We will take a break.
Alrighty. We'll be back in just a moment.
All right. The Cogito will be next. We are back with this wild puzzle from the Cogito.
I have to say, just having skimmed the rules, I love the note taking area that has been included.
Agree.
I think it's very handy when setters sort of include a natural way for you to take notes on the weird things that are going on in the puzzle. So in this puzzle, what we have to do is we have to fill every row, column, and box with the digits 1 through 9, except we can't use all of the digits 1 through 9. We have to repeat a digit. So we could, for example, drop 7, but repeat the 2. However, every digit is repeated in 1 row, 1 column, and 1 box. So, and likewise, every digit is excluded from 1 row, 1 column, and 1 box. And so we have here notes to indicate the digit that's repeated in the column. Here are the ones that are excluded in the columns, likewise for rows, and likewise handily for the boxes, for box 1, 2, 3, etc. So once we know what those digits are, we will be in pretty good shape, I think. The puzzle is called No Secrets Here, because, of course, nothing sums to 45 in this puzzle.
Yeah, and as Jim says, this is very Sortadoku.
Alrighty, so those are the rules, I think. So we get to do some interesting math to start, I suspect. It's funny, these 6 cells have the same sum as these 5 cells. Sorry, those 9 cells have the same sum as these 5 cells. Because these are the same. I mean, maybe even just saying these 6 cells have the same sum as these 2 cells is already pretty weird. But then also adding onto it that these have the same sum is also pretty interesting. But what is the minimum amount that 6 cells can sum to? It would be 16, right? So these sum to at least 16. So they have to be from 7, 8, 9. But they could sum to as much as 19 if this works. And so isn't it this that's the difference of the
18.
secret digits?
18 is the max sum.
Yeah, I said that, didn't I?
You
thought
said
it in
19.
my head. But anyway, Jay Dyer's point is that actually if you sort of add the, apparently I did say 19, I didn't mean to, 18, 9 plus 9 is the maximum. But if you add up all the digits in box 6 versus adding up all the digits in box 8, then the difference between them is the white digits. So the absolute maximum the white digits could sum to is something like, let's see, you could delete the 1 and add a second 9, I guess, is sort of the maximum difference you could make between these two things. Just sounds like a difference of 16 to me, as D-Web says. So these sum to at most 16, which is maybe not actually interesting yet, but it is good to note. We have similar weirdnesses like this single cell sums to these 4 cells. Again, these 4 cells sum to a minimum of 7.
So why don't we
1,
mark
2, 3. So this is also from 7, 8, 9.
Can we mark groups that must have must have
yellow
repeated
and white
digits?
are the same sum. Yellow and white are the same sum. That is the thing that Jay Dyer was trying to tell me that I did not appreciate. So this is actually a maximum of 16 and a minimum of 16, I believe, is what we concluded, right? Because yes, it is a maximum and minimum of 16. So the yellow does sum to 16. And the difference between these boxes is in fact 16. which means that we do have to delete the 1 from box 8 and add the so yeah, we delete the 1 and repeat the 9 in box 8, and we delete the 9 and repeat the 1 in box 4 in order to get our difference of 16. And in fact, remember that means that this really is 1, 1, 2, 3, 4, 5. Because we actually have to make these sum to 16, and there's only one way to do that. So we can get rid of all the 2's over here. And remember, in this box, the remaining digits are 6, 7, and 8 over here. Because we've deleted the 9, remember? You can see that down here.
So the rest sum to... So now we know the sum of the outer ring is 21.
Yep. Agree. I'm contemplating if I can do anything else with this and that, with the white dot. I know this isn't a 4, at least, I suppose. Because if this were a 4... Actually, wait, do I even know that? No, I don't think I do know that. That could be a 4, 2, 1. Sorry, no, 4 would be fine. And the 16 sum can't be 8, 8 because the only way this worked was to repeat the 9. So this 16 sum is 7, 9 for sure.
So how do you make 21 now? Are we gonna?
I'm gonna need the other 9 because I'm not allowed to repeat stuff anymore, and I'm not allowed to use a 7. But if I don't use a 9 and I'm not allowed repeated digits, I'd have to use 6, 7, 8. So I definitely use the other 9. But then you've got options, I think, because you could do 4, 8, 9, for example. Is 4, 8, 9 the only way, actually? Because 5, 7, 9 is gone. So this does have to be 4, 8, 9. Which means that these digits are 2, 3, 4. No, not 4. Sorry, 2, 3, 6. That's not
5?
enough digits.
5.
I repeat the. Sorry, 5. 2, 3, 5. Yeah, right. This box, I am repeating the 9, which I've done, and I'm not including the 1. So these are 3, 6, just because it's the only option. And so these are not 3 or 6. There we go. This is also a 2-cell sum to 16.
So they're from 7.
Does it have to be 8, 8? Is my question, or could it be 7, 9? I think it could just be 7, 9. Because I do I can repeat the 9 in this row, for example. I believe.
Or the 7.
Yes, or the 7. So I think we have to be a little bit careful with that. Okay, so, right, these 5s. I keep wanting to say, so this row sums to 63, but that's not true because it's all the way around. We have to include those sum to 21. It's funnily enough,
we know the
21
sum
plus 16 is 37. Hey, Pause, how are you doing? Right. Okay, so now DWeb points out the minimum of these 4 cells has gone up. Because previously the minimum was 1, 1, 2, 3, which summed to 7, but now we've already repeated the 1. And if I've already repeated the 1, now the minimum is 1, 2, 2, 3, which is 8. And I guess I might as well say, I know I need to repeat the 1, the 2, or the 3 in this box. So I can say for sure the digit that's repeated in this box is 2 or 3. because otherwise this would sum to not a single digit number. So that seems worth doing.
And those 4 cells only contain digits from 1, 2, and 3. Because 1, 2, 3, 3 is the max.
And I
could it be 1, 2, 2, 4?
2, 4. Yeah, so this you can do 1, 2, 2,
there are
4.
1, 2, 3, 4.
But there's certainly from 1, 2, 3, 4. Let's see. Likewise, these 3 cells sum to a single digit number. So they can't be very large either, but I don't know that I really want to mark that these are from, at most, maybe they could even be 6 or something. Yeah, they do include a 1 and a 2 for sure.
It's interesting that that white dot at the top of column 5 is going to restrain things, though I guess not hugely. But it is going to push up the other cells in that row up top.
I don't think so, Eckbert. Eckbert was saying that this white dot is going to mean this has to be a 3, 4, but I don't think so. I mean, this is certainly from 1, 2, 3, 4, 5. And I think there's some things we could rule out if we wanted. Like this can't be a 1 because we know there's a 1 over here. But I think this could be 2.
Oh, it could be 2.
Annoyingly. Because I could do 2 double...
No, the repeated digit in the box... The repeated digit in the box is in those 4 cells, and they include a 2. So that can't be a 2 in row 1.
Oh, is that true? Yeah, 1 double 3 would not work. And yeah, if I need a repeated digit here, so this digit can't show up down there.
And
so
we can't repeat it can't be a 3 either, because we can't repeat the 9 in this box. So 3 isn't big enough to get to 21.
Yes. Okay, so yes. So if this were a 3, these would have to be double 9. That's very smart. Okay, I was not going to think about that. So this is only 4 or 5.
Which limits what row 2, column 5 can be.
So these need to be, because I mean, at minimum, these need to sum to 16, right? 5, yeah, these need to sum to 16 at least. So again, these are from 7, 8, 9. And I agree that this can't be a 1 or a 2 anymore. So these are certainly from 6, 7, 8, 9, for whatever that is worth. Almost nothing, I suspect, is the answer. Funnily enough, if this is a 4... Oh, maybe not. I was going to say something, but I don't think it's quite true.
We can't have a repeated digit in box 2 in row 1, since we already have a repeated digit in the box. So they must include a 9.
Agree. They must include a 9, because you can't repeat both the 8 and the other thing.
So row 2, column 4 can't be a 9.
So this can't be a 9. I agree. I think that can't be a 9 either. Because I think the repeated 9, although I'm not 100% sure. We know we repeated a 9 in this box. Does that mean the row where we repeated the 9 has to be one of these? Yes, but I need, in order to prove that, the box where we excluded the 9 is over here. So there are 4 9s in these boxes, 1 in each of these 2 and 2 here. And so therefore the row where the 9 is repeated is down here. And therefore the digit here that's repeated is not a 9 in this row. And so I feel like I worked very hard to eliminate a 9 from a pencil mark that is going to do absolutely nothing. But what can you do? So,
If uh Sayori with a good point is that if row 1 column 6 was an 8, the consequence is that you end up repeating 8 in the box. Row 1 column 6. If that's an 8, you end up repeating 8 in the box.
because if this is an 8, that would have to be a 9, and then this would have to be an 8. Yep. Agree. So this is not an 8.
That was really good reasoning, by the way, about having to repeat a 9 in a row in the bottom thingy.
We also have to repeat a 9 in one of these columns for whatever that is worth.
You could in those cells you have highlighted, you could corner mark 9.
Yeah, I guess so. Yeah, let's corner mark that we know we're repeating the 9 in one of these places. Row 3, column 4 is interesting if you look at the line in box 1.
It does sum to 4 cells.
What? This cell? The one I have highlighted? This only sums to 2 cells. And it just
are those separate?
there.
Does the rules
These
say
must be separate lines, right? There's no way this is intended to be read as one giant line.
Well, the rules had better clarify that. Okay.
Yeah, this just means separate lines. That is if you don't say anything, these lines are separate when they cross at a 90-degree angle, because you wouldn't draw it this way if you wanted these to be the same line. There'd be plenty of other ways you could draw it.
Well, I would have read that completely wrong myself.
Yeah, these lines don't even, as Jay Dyer points out, these lines don't even share a cell. Okay. I wanted to do the corner mark some excluded ones and repeated ones just while we're at it, because we know that 1 is repeated in this box and it's excluded in this box down here. So therefore, there is a repeated 1 in one of these cells, and there's a repeated 1 in one of these, in one of these rows and in one of these columns. Just for the record. Okay. It is true that these 2 cells repeat, because these 2 cells are the same digit. I can ketchup them just for so that chat can keep track of the ketchup. So the repeated cell is ketchup in that row. So ketchup definitely isn't 1, right? If ketchup was 1, oh, maybe ketchup could be 1.
No, I mean, because it's the sum of 2 cells.
Oh, right. Ketchup
1
is the sum of these 3 digits. So these 3 digits certainly sum to a minimum of 1, 2, 2, 3.
You mean 1, 2, 2?
Oh, 1, 2, 2. Sorry, they sum to a minimum of 5. So yeah, so this is 5, 6, 7, 8, 9, and it's not 9 because remember the repeated 9 is down there, not in this row. So this is 5, 6, 7, 8. Let's see. Yeah, I wasn't sure if I was excited about marking that, but I'm going to mark it as Jay suggests. Definitely, because there's only 1 in in this I know that means there's only 1 in or sorry, that means there's only 2 rows with 1s. So one of these rows excludes a 1, and one of these columns excludes a 1.
Uh,
Up here. Sorry, I
D-Web
put the 1 in the wrong place. I put the 1 in the wrong place. I'll fix it. Sorry. Ah! Right. The 1 is excluded down here from one of those.
D-Web makes a great point that at the top of column 5, one of those 2 cells has to be a 4, which eliminates a bunch of stuff in the box.
That's true. 4 is not the repeated digit, and one of these is a 4, so none of these can be 4. Agree. So this is... Oh, no, sorry. I was going to say, so this is sort of a 1, 2, 3 triple, and that's the repeated digit, but that's not true. In fact, this just can't be the repeated digit, right? I think that can't be the repeated digit, but what have you.
That's a good point.
This box we can do some amount of math on. So we know those cells sum to 21, and these sum to either 16 or 18. So 21 plus 16 is 37.
Mm-hmm. Or 39.
So yeah, so these sum to 37 or 39. But because of the both including and excluding thing, I don't think we can quite do anything interesting with that without a whole lot of thinking about it. I think if we had excluded lots of digits elsewhere, I think we could do more. Let's see.
Oh, 37. Yeah, 37 doesn't work.
Right, sorry. Before, when we got up to 16, that was the difference between 2 boxes, not the difference between 1 box. Right. So the minimum difference between the digit that we repeat and the digit we delete is 6. I think is what we said. You said 37 or 39.
Yeah.
So the digit that's repeated has to be at least
2.
6 less than the digit that is
excluded. What? So you're
it has
right.
To be at least 6 less.
Yep.
So the repeated digit, so the excluded digit has to be an 8 or a 9. Oh,
yeah,
sorry,
we know it's not a 9.
Right. So 2 and 8 are the only way that this works.
Yes.
So in fact, 8 is excluded from this box is the point, right? So the point is the excluded digit from this box is 8, and the repeated digit in this box is 2, which means the repeated digit in this box is 3, which means for 2 different reasons, this digit is a 9. And we get to do our 9 dance. Let us bring out Zach. Ba-doop-ba-doop, wah! Ba-doop-ba-doop, wee! Ba-doop-ba-doop, wah! Thank you, Zach.
So now we know that row 2, column 5 is a 3.
So yeah, so on this line, there's 2 3s and a 1 and a 2. So there's not a 4. So that's a 3 and that's a 4. And so this is now an honest 1, 2, 3 triple for whatever that is worth. So within this box, let me remember what appears in this box. So we have no 8s. So we have to put a 7 somewhere. The 7 definitely doesn't go along here. So the 7 definitely goes along here somewhere. And then got a 6, which I think I could put with a 1 and a 2 there. And then we got a bunch of other digits. I don't think there's a lot. I'm prepared to mark with those.
So now, yeah. Now that we have a 4 on there, we need an 8, 9 to make 21.
Yep. Okay, so yeah. So yeah, now these need to sum to 17, but they can't involve repeats, so they just have to be 8, 9. And that 8 means both of those are 7. This is not 7, so circle is not 7 or 8 anymore.
It's 6 or 5. And the other one is excluded from the box.
So yeah, so the missing digit in this box is 5 or 6. I agree with that as well. Uh, and we've already repeated the 2 and the 3. So actually the minimum value of these cells actually is 6.
Okay.
Is D-Web's point. So actually this is a 1, 2, 3 triple and circle is 6.
Now we
Uh,
know 5 is excluded from box 2.
so 5 is excluded from box 2. I agree. And the double 6 here certainly rules 6 out of this cell because I can't, even in this madness, I certainly can't have a third 6 within the row. Let's see. So we've got that. And these two cells sum to 6, and they're not double 3 because we've already repeated the 3 in box 2. So these are 1, 5 or 2, 4. We have, let's see. Got a repeated 2 up there. Okay. Let's see. There's our double 6.
I'd like to pencil row 2, column 7
I'm
by
trying to
black
figure out what
dottage.
I know about where the double, what box has the doubled 6, given that this row has the doubled 6. Does that mean that one of these two boxes is definitely the one with the doubled 6? I'm not sure. I am somewhat confused about that, given that I don't know that things are excluded. Martin is
Look
thinking
at
about it from the other direction.
the
but
column, because look at the 3-6 pair in box 8. So 6 is going to be repeated in one of those two
Okay.
columns.
I was trying to figure out this this thing I'd been doing. I'd always had more information, but yeah, this is going to repeat a 3 or a 6. So beautiful. So this is 3 or 6, and funnily enough, that means this cell and this cell aren't 3 because we already have our repeated digit in the column. So those are an honest 1-2 pair. Oh, by the way, that's not a 4 anymore. What? We only get to repeat one thing in the column.
Yeah, wow.
So we've got that. So now within the column, we have 1, 2, 3s are taken care of, 4s. We might still need a 5. Our 6s are taken care of. We might still need a 7, an 8, or a 9. So this is 5, 7, 8, or 9, I believe. And one of these two does have a repeated 6 because of that 3-6 pair. That's what Martin was seeing.
I just said
that. I now understand what Martin's point was.
I just said
that. I believe you. I was just thinking about other things. Okay, so this digit's pretty big, so this sum has to be pretty large. Right. 1 is definitely not excluded from this column because this column has an honest 1-2 pair. I agree with that assessment. Yeah, the 3-6 logic was beautiful. I didn't see that it involved these 3-6 pencil marks when you were talking about it in chat, Martin. That was the part I was still quite absorbed by. So these cells can't be 1, 2, or 3 because we already know where 1, 2, and 3 are repeated. So I'm just going to mark for the future that these are 4, 5, 6, 7, 8, 9. Not that one, of course. And these certainly aren't 6. Do I know anything else that these aren't? Maybe I don't yet. I don't know that these aren't 9 because I don't know that the 9 doesn't repeat yet, I don't think.
We know that row 6 column 4 and row 6 column 6, one of those two is the repeated digit in the box.
I want to mark Jay Dyer's point, which is that if you count the 3s in this stack, there's 2 3s here, 1 3 here, and 1 3 here. So that means the repeated 3 is in these cells. So that actually gives us a 3 6 9 triple in repeateds up here. And we know this one isn't the 6 because we already proved that one of these two is the one with the repeated 6 because of that. So we know that. Thank you, Jay. So your claim is one of these is the repeated digit for box 5, Tristan?
Yeah, because there's nowhere else to put it in the box. Because you can't put it in row 4, and it's not on that 1 2 3 triple. Oh, I guess it could go in row 5, column 5. A bunch of people are saying
the even digit on this dot, there would be a 7 8 9 triple in the row, which would make these exactly a 4 5 pair, but I don't see that as immediately being a problem.
I'm trying to understand D Webb's point that 6 has to be the repeated digit in box 5.
Yeah, this
row
can't
5
be a
column
repeat because
that can't be a repeat. So my point was right.
Oh, it can be a repeat within the box. It just can't be a repeat within the column. So I don't think
so
think
that
it's quite
can't
correct.
So that can't be a repeat. So
it can't be a repeat within the column, but being a repeat within the column and being a repeat within the box are different things. There's no like what thing is the repeat. It's not like we could like circle or shade all the cells that are repeated. That's not how it works. I only know that because I did a different Cogito puzzle with a similar rule set. So yeah, there's no like canonical. This is the
so
repeated
here's
one
a good
thing.
point that is related to what D Webb was saying. Row 6, column 6. If it is a 6, it's a repeated 6 in box 5. If it's not a 6, then 6 is excluded from column 6.
Okay. I'm not corner marking a 6 across this column. Which is what you want me to do, but
no, not exactly.
Oh, sorry, no, I would be corner marking a 6 between there and there, is what you're implying.
Yeah, but I don't want you to corner mark it. I just want to observe it.
Row 5, column 8 cannot be 1 by dottage, right? This can't
That's
be
true.
2 anymore, so this isn't a 1.
Well, you can't repeat the 2 in the box. And there's dots above and below it.
Let's see. So this is always even. So this is definitely not a 4 anymore. It's definitely odd. It's 1, 3, or 5. Let's see. Again, this sum is pretty big. This sum is a minimum of 9. And so 9 plus 6 is 15, plus 21 is 36. Oh, actually, that's not even big enough, because the minimum sum of a box can possibly have is 37, right? But we actually could do way better than that, because if we want to minimize the sum of a box, the best we can do is repeat the 4 and delete the 7, just based on the digits we've already deleted and repeated. So if you delete the 4 and repeat the 7, repeat the 4 and delete the 7. I said that backwards. Then you end up with the sum of 42. So the sum of box 1 needs to be a minimum of 42. However, these cells only sum to 27. What's 42 minus 27? Is it 15?
15.
I think it's 15. So these two cells need to sum to a minimum of 15. Oh, and Jay Dyer points out, in my optimized version, I deleted the 7, but we can't delete the 7 because the box has a 7. So actually deleting the 6 is the best that we could do, which means these two need to sum to at least 16, which means they're certainly from 7, 8, 9, as are these down here, right? That's not using anything fancy about repetition or anything like that. So we've got that.
But let's see, if we repeated the 7, does that break anything? I don't know.
So certainly that math would let us pencil mark something here and something here, but I'm going to let chat tell me what digits go there and what digits go there, because I don't want to do it in my head.
Right. Row 4, column 4 is just a 9 because we can't repeat 7 or 8 in that column.
Yes, that's true. Good point. Yeah, so the repeated digit in this column is known to be 3, 6, or 9, and we've already got a 7 and an 8, so this just has to be 9.
That was Jay Dyer's point.
That was a good point too. Oh, to Jay Dyer. And so now these cells can't be 9.
J40 also.
We've already repeated 9 in this box. Sorry, in this box, so we can't repeat 9 in another box.
Right, so that means row 5, column 5 isn't 9 as well.
Yes, this also isn't 9. Okay, so now the sum is 16 or 17. So those are the options. Let's see. There is a 7, 8, 9 triple in this column that is an honest 7, 8, 9 triple in this column.
Yep.
I guess what it tells me is that one of these two cells is definitely 9. But I don't know that really...
Yeah.
I guess it does do something. One of these two is definitely 9, so neither of these can be 9. Because if either of these were 9... Oh, no, I don't think that's true. Never mind. Ignore me.
It's pretty simple math to show that row 2, column 2, and row 3, column 3 can't be 7. Because then the box adds to too much.
So then the box adds to too much. So if we repeat the 7... Oh, right, yeah. If we repeat the 7, because, right, we're basically minimizing this. If we repeat the 7, then... and delete the 6, then the box sums to 46. And so this would have to be 21 plus 6 is 27. 46 minus 27. These would have to sum to 19 if I'm repeating the 7, which doesn't work. So yeah, so these can't be 7. I agree. I would not describe that in any way as simple math. 9 is not the repeated digit in this row, by the way. 9 is repeated in one of the rows down here, so this is definitely an 8. Just by Sortadoku. Yeah, I like Jay Dyer's framing of counting this in terms of degrees of freedom. So the sort of the repeat the 4, delete the 6 leaves 2 degrees of freedom. So you can only repeat, in fact, the 4, the 5, or the 6. And you can only delete the 6 or the 4, I think, because of that.
Martin points out we've already repeated
right,
the 8.
Right.
In a box.
And even better, it doesn't even matter, because as Garion points out, I literally just said you can only repeat the 4, 5, or the 6. So you certainly aren't repeating the 8. So therefore you repeat the 9. And that means that is an 8 over there. Okay, good. Yes, 8 has not been repeated yet. But we can't repeat the 8 because of the 4, 5, 6 debacle.
Because of previous logic.
And so now I know the sum of the box. now the sum of the box is 21 plus 17 is 38 plus 6 is 44. So the digits I'm adding and deleting are consecutive, but this one seems only to be able to be 4 or 6. So it must be that I'm repeating a 5 and deleting a 6, right? That's the only way that's going to work, because I need to because of the fact that 5 has already been deleted per Tristan's earlier observation. So I think that's a 5 and that's a 6 is the only way that works if I did that math right. Please tell me if I did that math incorrectly. So we've got that all going on, if I did that right. Okay, so funnily enough, now we're now actually in a sort of fascinating situation where in these 3 rows, I have repeated a 5 in one of the boxes and deleted a 5 in another one of the boxes. And so I think that doesn't tell me that there's necessarily a row where 5s are repeated or a row where 5 is excluded over here. Now, if I look at this column, I know that the 5 is excluded in this box and it's not repeated in any of these. So I do know the 5 is excluded in one of these columns. Okay. So let us see. 3, 6, and 9 are the repeated digits in these columns. Row 9, column 5 can't be an 8 because the repeated digit in this column is a 3 or a 6. So Sarah points out, so that's a 9. And the repeated digit is not a 9 in particular somehow. Is that real, or did I just did I screw that up?
No, that's
Do I
real.
really know that repeated digit is a 9? Oh,
Yeah.
right, because the repeated digit is the 3, 6, right? So so that is a 7, and that's a 9.
You have a legitimate 3-6 triple.
Yes, a legitimate 3, 6 triple. And now I have a weird 7, 8, 9 triple that may or may not be an actual 7, 8, 9 triple. And these can't be 9 anymore. Sayori pointing out this is also not 8 because, again, the repeated digit in this column is a 3, 6, or 9. So that's a 4, and that's an 8.
Which takes 8 out of column 6 as well.
Yes, because, again, the repeated digit is not 8.
Oh, the repeated digit in column 6 is 9, because we have 2 9s in the column.
So that means that we actually have this 1, 2, 3 triple now, because the repeated digit can't be 3. So this 1, 2, 3 triple now actually makes this a 5, which then makes this a 6 and a 3. And that had better be a 2, because 1 is the deleted digit, not 2. So we've got all of that over there.
Now 6 is the repeated. You can resolve that
column. So that's 6 and that's 3. Over here. So one of these 2 cells is our repeated 3 in the column.
Oh, 3 isn't repeated in box 5, is it? No, it's not. So we... No, it can.
We don't know what's repeated in box 5.
No, but 3's already been repeated in box 2.
Oh, right. Okay, yes, you're right. Sorry, 3 has already been repeated in box 2, so it can't be repeated in box 5. So therefore, it must be there. Good. Okay. Yes. Okay, this column's repeated digit is not a 5, by the way. Let's just do a little bit of cleanup. So I think these are 4, 6, or 7. If we look at those. Uh, 1 is now forcibly excluded from column 4, points out DWeb, so I can fill in that 1 down there. Because that's not 1 because of this 1-2 pair. Let's see. I should know what's deleted from this column. It's 5 is deleted from this column. And the thing that's deleted from this column is a 4, 6, or 7. I believe. This is not where the... Oh, no, sorry. This could be where the 9 is repeated. Never mind.
Yeah, you might as well just fill in the bet tree.
So the bet tree, we're saying has to be a 5?
Yep.
Because, right, so the column doesn't delete the 5, so that has to be a 5. So congratulations to all the 5 bettors out there.
Lots of 5 bettors.
5 is always a popular bet. Unfortunately, 5 could be repeated there. 8 could be repeated in this row. 6 is repeated in this row. It's definitely not a 7 on this white dot. Oh, you're right. There can't be an 8 on this dot either. So the even digit on this dot can't be 8, because if it was 8, it would either connect to 9, which it can't because 9 can't repeat in the row, or to 7, which would break this cell because, again, neither 7 nor 8 can repeat in here. So at the very least, the even digit on this dot is 2 or 4. So that restricts this at least to being between 1 and 5.
So you can reflect that up into box 1.
I mean, I could say that this is up to 6. Oh, but 6 isn't repeated in this here. So this is from 1, 2, 3, 4, 5. Yep, agree. But Sayori points out I need to remember this is part of a region sum line that adds to a bunch. And so these two add to a maximum of 16. Sorry, no, 17. These two add to a maximum of 17. If they're 8 and 9, because I can't repeat the 9 in a column again. And so, therefore, this needs to be at least 4. So this is not 1, 2, or 3. And so those can't be 1 or 2 either. So we've got actually all of that going on. And so that means that these digits, in fact, because the maximum this now sums to is, or the maximum of this is now 5, these need to sum to a minimum of 16. So these are 7, 8, 9 again. I don't know anything about whether the 8 is repeated here. I guess I do know that this is from 6, 7, 8, 9, but it's not a 9 because the 9 is repeated in that column.
Sayori points out the even digit on the white dot in row 4 is a 4, which looks over.
Yes, correct. Yeah, one of these two is a 4, which sees that, which makes that a 7, makes that an 8.
That 4 still sees into box 6.
Yes, you want those two as well. I was debating if I knew that the 8 knocked 8 pencil marks out of these, and I do, because I know the excluded digit, or sorry, I know the repeated digit in this box is a 1. So I actually know that these are a 6, 7 pair. And then I was looking over here to see if I know that if 8 could be repeated in this row, and I think it could be, as best I am aware anyway. Row 6, column 8. Because the only way this would be a 1 is if this went 1, 2, 4, but it can't anymore. Agreed.
Why can't it go 1, 2, 1?
because the 1, oh, it could go 1, 2, 1. Never mind. Sorry, it could go 1, 2, 1 because this could be the column where 1 is repeated.
It could also go 3,
Uh,
2, 1. So
yes, but the point was that this couldn't be a 1, but it's not true.
yeah, 1, 2, 1 still works.
7 is not the repeated digit in this column, so this digit's not a 7. 7 is certainly not the excluded digit in this column. The excluded digit in this column is a 4 or a 6. So we have all of that going on. Sayori points out this can't be a 4 because if it's a 4, we actually have each digit once. That's funny. So this has to be a 6, so that the repeated digit in this box is a 6, and the excluded digit in this box is a 4.
Yep.
And that 6 has already been repeated in that row, so it's not repeated there. So that's a 7 and a 6 that go into the grid. Now the even digit on this row, 6 is already repeated there. So the even digit here is an 8, and it is repeated in this row. So the repeated digit here is an 8, and here it's a 1. But one of these has to be an 8 because of that. This box, I don't know what the repeated digit is. Let me fill in this triple just so I know. 1, 2, 3, 4, 5, 6, 7, 8. 4, 7, and 8 are the digits we have not yet repeated. And let me look at excluded digits because maybe that one's easier. 2, 3, 4, 5, 6, 7. 2, 3, 7. Okay. Do I know any of those digits show up here for sure? Or show up here for sure, or show up here for sure? I don't think so. Of course, it will be quite a thing if 7 manages not to appear in these cells, but I don't know that I can rule it out. Maybe if I do white dot plus 21 math, maybe it could.
Yeah, there's nowhere for 8 in row 2. J. Dyer points out. Just try and put an 8.
This isn't an 8?
Because 5 is the repeated digit in box 1. And you would be repeating an 8.
I would be repeating an 8 in box 1, right? Okay, so yeah, so I can't put an 8 there.
And 8 is excluded.
These 2 cells, right? I can't put 8 in a 3-cell sum to 9.
8 is excluded from box 3. It's much simpler than
8
that.
is excluded from box 3. Okay, very nice.
So,
okay. So 8 is excluded from this row.
Yeah.
So now there needs to be an 8 in this row, which means that there's a second 8 in this box, is J. Dyer's point. So one of these is the 8 for row 6, but there's an 8 up there already. So therefore, we're definitely repeating the 8 in this box. I agree. So now we can't repeat the 8 down here. So now this sum to 16 is not 8, 8 anymore. It's now 7, 9. I bet that broke the cogitator's heart when that happened. This is not the column with a repeated 9, by the way. So that's a 7 and that's a 9. So this is the row with the repeated 9. We now see. There we go. Okay, so the repeated digits are 4 and 7 down here.
Yeah, no, there's nowhere for 9 in column 9, points out D-Web. It's true.
Nowhere for 9 in column 9, because I can't repeat it in this box, and I can't repeat it in this box. That's true. So 9 is the deleted digit in column 9. I agree. Let's see. 9 in box 7. Certainly not in those cells. There's certainly a 9 in one of these two cells, right? If there's not a 9 in one of these two cells, these sum to a maximum. No, I could just barely make this 8, 8 with a 5, right? I don't think I know this isn't 8, 8, do I?
Josh points out there's interesting math to be done on box 4 and box 7 because of the region sum lines. Box 4 and box 7.
I understand. I'll let you do that. This looks excruciating, but I'm sure we can do it. So the point is that these digits have the same sum as these digits.
And the difference
so
is
this is
minimum
another
9.
the difference of the secrets math.
The difference is minimum 9.
Sure. So if we maximize the repeated digits, sorry, no, we want to if we maximize the difference, we'd get a difference of 4 over here and a difference of 5 over here. Okay, this is not as bad, not as horrible as I thought. The difference, because the difference of the two boxes is going to be the difference in these plus the difference in these. And so the difference in here is 4 at max, and the difference over here is 5 at max, which is 9, which was the minimum possible difference over here. So this is a 3, this is a 4, this is a 7 and a 2 and a 3 and a 7.
Wait, how did we know which of 2 and 7? Oh, I got it. Yep. So that gives you row 4, column 1 as well.
Yep, so that's a 4 with a 3 or a 5, and now I have to actually sort of internalize that we're repeating a 4, we're not using a 7. We know we're repeating that, we're not using a 2. It was nicely spotted, Josh. Let's see. Even if it killed my soul just a little bit.
Yeah.
4 here needs to go with an 8, 9. Otherwise, we're not getting to enough. So these are an 8, 9. Let's see. And we haven't repeated 8 in a row yet. Oh no, we have repeated 8 in a row. It's that one. We haven't repeated 8 in a column yet. So these I know aren't 8. But I don't quite know more about that. Let's see, there just is no 7 to find in this box. Okay, I want to do Jay Dyer's point, which is that if I look at the first 3 columns, to start, it's 3 sets of the digits 1 through 9. But then we add an extra 5, an extra 8, and an extra 4. And then we delete a 6, a 2, and a 7. So certainly that means my repeats have to be 5, 8, and 4 because there's 3 of them. Up there, and so that means that these are the other ones, which are 1, 2, 3, 4, 5, and 6.
7, not 6.
Sorry, 7. Thank you.
Although
long time says row 8, column 3 is a 9. Okay, so I can't repeat 9 there. I can't repeat 9 here. I can't repeat 9 there. So one of these two is a 9. How do I know which one it is? Oh, because that's a 9. There we go. Okay, yeah. So just by Sortadoku, Longtime points out this digit has to be a 9. I agree eventually once I see all the 9s that are looking at this box. Yeah, and so these are 2, 6, and 7 for the same exact reason. We could just fill those in. So that makes that a 4. Is the deleted digit from this column, which I guess we already would have known if we just looked at the column some moments ago. Okay, and so these excluded digits are 2, 3, 4, 5, 6, 7, 8. These are 3 and 8 are the excluded digits. Now, this column can't be missing 6 or 7 because it already has a 6 and a 7. So this is missing a 2. And so that digit's not a 2. So that digit's not a 4. Uh, hmm. Uh, Row 5, column 3 is 5. 5 is not excluded from box 4.
Yep.
Or
Sortadoku
repeated
by
in row
Sortadoku.
6. Yeah, okay, you're right. This 5 can't go here, but it's not excluded from the box. So the 5 goes there. And now it's not repeated in the row, so that's not a 5. It's not repeated in this row either, so that's not a 5, and that's not a 5. It actually places the 5 up here. So we've got that. 1 is repeated down here. 8's repeated here. 3 is not repeated in particular in this row, so that's not a 3. It's a 1 or a 4. So this is an honest 1, 2, 4 triple, where the 4 is over on this side, and 4 is not repeated in this box, so that can't be a 4.
You have a pointing octuple in row 4, and we know what the remaining digit is. It's a 1.
Okay, so yeah, we did not exclude 1 because the 1 is excluded down here. So that is 1, 2. One of these cells is a 1. That's a 1, so this is a 4.
Yep.
2 is not the repeated digit in this row, so that's a 1, and that's a 2. 2 is not the repeated digit in this column, so that's a 1. 1 is not the repeated digit in this box, so we have that. 1 is not the repeated digit in this row, so that's not a 1 for what it is worth. Let's see. If I look at what's deleted in these, we've both deleted and repeated a 5, so that doesn't tell us anything. But we've repeated a 2 and a 3, so we know the double 2 and the 3 are in here because we've added them without deleting them.
Those are just 2, 3, and 5 by previous logic.
I don't think.
Oh wait,
so.
no, sorry.
I think you.
I am wrong about.
We've got this combination, so we've added a 4 and a 9, but not taken it away. So I do need a 4 down here. Yeah, I was thinking, Cogito, that there might turn out to be some global deduction that meant that didn't work, but I don't think there is. If there is, I have not seen it. Let's see. And so, yeah, I guess I can do the same thing over here and say that we've deleted 6 and 8. So one of these rows is missing a 6, and it's not this one. So the excluded 6 is here because we've only got 2 6s in this string of boxes. In this string of boxes, we've deleted a 2, a 4, and a 9. And added none of those. So these are a 2, 4, 9 triple. And that one is not a 2 or a 4, so that one's a 9. And this one's not a 4, so that one's a 2, and that one's a 4. And the 9 being excluded actually forces that to be an 8 and a 7. I have an odd feeling that J Dyer told me this was 249 an hour and a half ago. Sorry, J Dyer.
Uh,
These
Now row
are
6, column
there's
1 is a
definitely a
9.
3. There's a 3 in one of these. Let's note. Let's finish this before we go do other things. So we've removed a 3 down here. That's certainly not the place where we removed a 3. Okay, now you were saying
Row 6, column 1 is a 9.
6 column 1 is a 9, right? Because these need to add to 21, and if I make this an 8, they do not.
Now we need an
Agree.
8.
So
well,
what can this digit actually be? Because it's not a 1, 2, 3, 4. It could be a 5. It's not a 6. Could be a 7, and it's not an 8 or a 9. So this is only a 5 or 7, which I thought was going to be more exciting than it turned out to be. If
There's
I'm
a
honest.
1-8 pair to
These two. I want to finish pencil marking these first. Let's do that real quick. So these are not 1, 2, 3. Could be 4, 5, not 6. Could be 7, not 8 or 9. So these are 4, 5, or 7. This one's definitely. Oh, sorry. This is the repeated ones, not the missing ones. Let me make my brain work. Okay. Weirdly, these form a very bizarre quadruple. Like this is the weirdest quadruple I've ever seen in a puzzle. Because these include 3 of the 4 digits from 2, 3, 5, and 7, but we can't use all of them. So these digits can't be 2, 3, 5, or 7. So could be 1, not 2 or 3. Could be 4, not 5. Could be 6. Not 7, could be 8, not 9. I think. Oh no, right. Sorry, DWeb is right. That doesn't work because this could form part of a quintuple of that because I could double the 2 or the 3. Right.
Yeah.
The double in row 3 can mess that up. Right. Okay.
2 things. DWeb is right that that if you look at our excluded digits, that we have left. Those are a 1-8 pair that you have highlighted. But if you look in our excluded column, we have 1, 3, 5, 7 left, but row 8 is a naked
this digit
one.
this just has a 7 in it. So that's a 6 and that's a 7.
Yeah, row 8's excluded digit is a 1. Because it has 3, 5, and 7.
You just want me to fill this in. Okay. So yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9.
No.
And this one is
9 has already been excluded.
3, it's not 3, 5. Oh, 9 has already been excluded. But the point is this is not 3, 5, or 7. It just is a 1.
There we go.
I like that you interrupted me doing this in order to make me do this, by the way. We have that. This one's certainly not the 7 because there's already a 7 in the row. Yeah, so we've got all of that going on. Okay, so we know the sum of these digits, interestingly. Although I guess maybe it's not going to tell us anything interesting because that's 21 flashbacks. So funnily enough, this box sums to 42, but we already knew that because of that. This can't be a 1 because the repeated digit Eckbert points out in this row is not a 2. So that's an 8 and a 4, and that's a 1. Going on here. So now these two sum to 13. So these two need to sum to 8. They can't be 4, 4. And they can't be 1, 7. So they are either 2, 6 or 3, 5. Now this can't be a 2 by the row, so that can't be a 6. This can't be a 3 by the row, so that can't be a 5. This can't be a 6 by the column, so in fact it is 3 and 5.
So 5 is repeated in row 8.
Sortadoku. So 5 is repeated in row 8. Good. And 5 could be repeated in this column for all we know. Okay, there's a 1 and a 5 here. 1's at least not repeated in this column. Maybe 5 is. This digit can't be an 8 by the row, and therefore I can't repeat 8 in this column. Because if I try and repeat 8 in the column, well, I can't. So this can't be an 8. There's just nowhere for a second 8 to go. And so this must also be a 4 or a 5, right?
Yes.
Oh, by the way, as Sayori points out, this does finish the 6th sum, which is that's a 4 and that's a 2. And so this is a 4 or a 5. Just to be the repeated digit in the column, because we've got 1 4 and 1 5, and we need to repeat one of them, so that's a 4 or a 5. Okay. What can these be? Let me fill them in. 1, 2, 3, 4, 5, 6, 7, and 8.
Not 8.
Not 8. But the 4 is just down here, isn't it? Isn't that what this corner mark meant? Didn't I know there had to be a 4 down here? I did know there had to be a 4 down here, so that's definitely a 4. These aren't 4. Because the point was I knew that there were 4 4s in these 3 rows. So these are indeed 2, 3, 5, 7. And this is the messier ones where I don't immediately know exactly what to do with them. Oh, this can't be a 5 because the repeated digit in this box isn't a 5, so that's a 4. Points out Amnosti. So yeah, and so 4 is the repeated digit there. Let's see.
Right. Now 4 is the repeated digit in column 3, since those two cells were the same.
Oh, right. Yep. So the repeated digit is a 5 or an 8. That digit can't be 8, but it could be 5. This digit can't be 5 or 8, actually. So this digit must be 5 or 8, right? Yeah. Let me double check. This can't be 5 by the by the box, and it can't be 8 by the row. So yeah, so this has to be the repeated, so it's 5 or 8. However, the repeat for box 1 is not 8, so this is just a 5, which means the repeated digit for the column is a 5. The repeated digit for this column is an 8. Unfortunately, the repeat for this box is a 5, so that could still be 5. We do still need to fit a 1 in this box somewhere.
We can finish column 2.
It'll be in one of those 2 spots. Yes, this column is not excluding a 1, so that is a 1. Let's see. This black dot, let's see, this could be 1 or 4 or 6. Those are the options. However, it can't actually be 4 because 4 is not the repeated digit in this column. So this is 1 or 6. I don't think I know which one yet. If this is 6, these would have to be... no, this can't be 6, because if this was 6, these would be a 1-2 pair, and that would repeat both 1 and 2. So that is a 1 and a 2, making that the second 3.
But where does 6 go in box 3? Or row 2, if you want to look at it that way. Where does 6 go in row 2?
Column. It's not in this row at all.
No, I'm talking about row 2.
And it's not in... It's... So... it is in this box, though, but it's not in this row either. So it is there, is your point.
Though somebody else had this.
Now
I think Marty had this point before
because
me.
those need to sum to 9, which now means 2 is the repeated digit in this column. So 2 is not the repeated digit in those columns.
1 is not the repeated digit in this column, so that resolves the 1, 3 in box 6.
Yep, sure does. So that's a 3 and that's a 1. So now 1 is the repeated digit there. 7's the repeated digit there. 7's not the repeated digit in this column. 7 is excluded in box 7.
So those can only be 2, 6, 8 by math.
Thank you, Plonk Time. I mean, we just know it's one set of the digits 1 through 9 plus a second 4 minus a 7. So I'm going to believe that these are 2, 6, 8. We're not repeating 8 in this row. So we don't have that. Let's see. Does we get any help here? We're not repeating 6 in this row. We're not repeating 2 in this row. Ye Old Chocolate Teapot triple. And we can do similar stuff up here. So we still need a 1. We've got a 2, and we don't need a second one.
We need a 1. We need a 1, a 3, and a 5.
And a 5, okay. And 1's not the repeated digit in this row. So the 1 in the box has to go there. Oops. I was trying to get rid of the corner mark there. Let's see. Lakia says we need a 1 in row 7. So one of these two has to be a 1.
Yeah, but it's already repeated in column 7.
There's already 2 1s here. Got it. So the 1 has to go there. Thank you, Lakia. This row needs a 6 and an 8. Is that correct? Yeah, it doesn't have a 6 or an 8, and it needs both. Oh, by the way, 3 is no longer the excluded digit from this row. So 5 is the excluded digit. Which means 7 is the excluded digit up here, and 3 is the excluded digit down here. That 7 at least goes over there. Now, if 7 is the excluded digit, it's definitely not the repeated digit. I am prepared to claim. So 2 or 3 is 2 is the repeated digit. We can just see that the 2 there is the digit there. Now 2 is already repeated, so 3 can't be, so that's a 5. 5 is the repeated digit in this box, but it's already been repeated, so that's a 3. Now 3 is repeated in this row, so that's a 3, and that's a 7. That's not a 7. 1, oh no, we've got 1. We've got 1, 2, 3, 3, 4. Oh, we need a 5 in this row, I believe. If I did my Sortadoku correctly. And this
7
row
has to go in the upper right
1,
corner.
2, 2, 3. I think we're missing a 4. If I have done that correctly. Let's see.
We
3
need
is no longer excluded from this column, so that's an 8, and that's a 3. So we need 2 3s in this column, and we have 0 3s in this column, if I understand correctly. So I think that's double 3, if I understand it correctly. Oh, no, sorry, 3 is excluded. Sorry, 3 is excluded, not doubled. Sorry, I need 0 3s, not 2 3s. So what is left? We've got 2, no 3s, 4, 5, 6, and 8. And down here, we don't get to repeat the 8, so we have an actual 2 6 pair.
And up top, we don't get to repeat the 8, so we have an actual 2 6 pair in the column.
And if that's an 8, then that's 6. And if that's a 6, then that's now a 2, which means that's now an 8, and that 2 looks over and means that's now a 6, which now means that's a 2. This row is missing a second 7 and a 3, I think.
Yeah, but we know which is which.
Yeah, because this column doesn't get to repeat the 3, so that is a 7 and a 3.
No.
What?
What? Oh, wait. Hang on.
Yeah, this is a 7 and that's a 3, right?
Okay.
The rare moment where Zeta is correct. Okay, so this column, we need 2 7s. So one of these 2 digits is a 7, and it's that one. So, and then the last digit is a 2. This row, we've excluded 1. So we've got 2, 3, and we need a 4 because we don't have one yet.
Yeah,
Yep,
first off,
I'll delete the outside cogito once I'm done. I need the outside until I'm at the very end, or I'm never going to be able to do this. This is missing. Okay, it's supposed to be missing a 3. We've got a double 4. We need a 5. Oh, it actually triggered without me deleting anything. Wow,
Sven
what a
is
puzzle.
smarter than...
I can only begin to imagine what setting that was like. This must have been an absolute nightmare. How many times approximately did you break this puzzle in the process of setting it? I can only imagine the answer is a lot. It's funny, you submitted a puzzle with very similar rules to a previous challenge, but I think this one was even more constrained than the last one, because the 5-less challenge, you submitted something where it was like, instead of 5, there's an extra digit, but I don't think it had any of the sort of extra structure that's imposed by the repeating and rows and columns and boxes, which seems incredibly restrictive. Well, it was worth it. It was quite a puzzle. So well done on that cogito. Yeah. I'm very glad that I had chat to help out with some of the logic in this. I did appreciate that every time I dreaded doing box math, it turned out the box math wasn't actually as horrible as it was going to be in my mind. It took you a month to set. That doesn't surprise me. This is quite an ambitious construction. All right.
So
we're certainly going to take a break. Are we going to then come back and do a 6x6?
Yeah, let me see if there are any. I mean, the next Sortadoku is a 6x6.
Yeah, but I don't believe that doing Sortadoku puzzle, unless it specifically says that it
Estimated
is
difficulty 3.5, so probably not.
Alrighty, but we'll come back and we'll do something. And then we will return.
All right. See you soon. Okay, here we are with Dorlier's 5x5. Want to take us through the rules?
Yes. So we have normal Sudoku rules. I'm not quite sure that that's really what is intended. I think what's intended is normal
Latin
Latin
square
square
rules.
rules. I think we're saying that every row and column has the digits 1 through 5, and there are no regions. Shade some cells so that all shaded cells are orthogonally connected, and all unshaded cells are orthogonally connected, and no
Yin
2 by
yang.
2 is fully shaded or unshaded. So standard yin yang rules, if you've seen it before, we have to shade and unshade everything. And there's a couple non-obvious consequences of this. One of which is that the border is sort of broken into a shaded and an unshaded contiguous piece. And the other is that you can't do any checkerboarding stuff. Like this is already broken because if you try and connect the yellow to the yellow, then you prevent yourself from connecting the gray to the gray. Yes, the border can be all one color. That is also possible. Not in this puzzle, though, Jay. Because each cell in row 5 tells you how many shaded cells there are in that column. Furthermore, in each column, the shaded digits in that column must increase in value, going from either top to bottom or bottom to top. Yeah, I'm just trying to think, Jay, if I've actually seen that happen. Someone once told me that in certain pencil puzzle circles, that's actually explicitly forbidden in yin yang rules, that they just expressly say you can't have the border be monochromatic because that would, I guess, be boring or something. And then cells separated by a V sum to 5, but not necessarily all of them are given. So I guess I can go ahead and mark that these are from 1, 2, 3, 4. And
these digits look huge after the last puzzle.
So a 3 at the bottom, so is either going to have a 4 and a 5 shaded above it, or a 2 and a 1 shaded above it. It would make a lot of sense for this to be the 5, but I don't necessarily know. So we do know, by the way, wherever the 5 is.
No, it's totally there.
The point is, this is a 1-4. Because wherever the 5 is, unless the 5 is here.
It can't be. That cuts off
the 5 can't be here. Right. So
it'll be, if it's anywhere except the leftmost cell, it breaks the 2 by 2 rule.
Yeah, they can't connect, right? So the 5 can't possibly be in the middle, and the 5 can't be here either, because if the 5 is here, it separates the 2 places. So in fact, the 5 is here, and all of these are shaded, and we actually get to go 4, 3, 2, 1. And the thing I was about to argue was that because of the 5 having to go somewhere, this had to be 1-4. Like that. Okay. So these are 2 and 5. Sorry, 2 and 5, not 5 and 8. Yellow is shaded, yes. Yellow is shaded, light gray is unshaded, is the standard zetamath coloring. So we've got those. Okay, so the number of shaded cells in this column can't be larger than 3 at the very least. No, what normal people use is they use this gray for shaded, or black for shaded, whereas I use this like slightly off white for unshaded, which is I think not an insane choice.
For me, I use light green for unshaded and purple for shaded.
I have done that, and I have used green in the past, but it's a little bit weird. Uh, I think yellow is the most bold of the colors in the standard palette, which is why I use the yellow, because it's the one that's most sort of the colors. Just the way that it is done. Uh, so this is 1, 2, or 3 for sure. Because 4 would force a 2x2. Yeah, not every cell over here is shaded.
Yeah. Row 5, column 3 adds to 5 with row 5, column 2, points out D-Web.
That's true. This is 2, 3, or 4. I do need a 4 somewhere. I'm trying to think about what the 4 is going to look like in terms of the thermo, but I think I don't quite know enough yet. I don't think either of these can be 4, actually. I think if either of these is 4, it puts a 1 in a very inconvenient place. Because if either of these is... it could be 4, 3, 2, 1 in either order, Jay. But also the 4 itself could be unshaded. And if the 4 itself is unshaded, then it is 1, 2, 3, 5 in some order. Yeah, I think that I don't think that quite follows, because I don't think the 4 has to be shaded. I think it could be I think it could be a 4 down here with 5, 3, 2, 1. But I think in any event, I don't think either of these can be 4 in any of these scenarios, because I don't think that this being a 1 fits with any of those. Because I need the 1 to be part of the thermo in order to make a length for thermo. So I don't think either of these can be 4. And if neither of those can be 4, this is now a 2 or a 3, which now means these aren't 2 or 3, which now means that's 1 and that's 4, which means that's 4 and that's 1, means that is 2 or 3. And now, because, I even could do something ridiculous like that, couldn't I? I believe. This being a 2 makes that a 5.
Yeah, I don't think 2 or 5, if row 5, column 2 is a 3, I think that 2 or 5 in row 3, column 2 breaks the thermo.
Trying to find row column labels. There we go.
So I think row 5, column 2 can't be a 3, as Josh points out.
Because if this is a 3, the shaded cells have to look like this.
And now what?
Yeah, and now
you'd have to go
3, 2, 1 or 3, 5, something bigger than that. Yeah, okay.
Right.
So that's true. Yeah. So if this is a 3, this is the only shading that works. But it doesn't actually work with this 2, 5. Yep, agree. So this is a 2, and that's a 3, and so that is a 5 and a 2. Okay, now that 2, I think, tells me that my shaded cells have to go up and be 1, 2, 3, 5, because otherwise, because I can't now have a shaded thermo ending at the 4. Oh no, I could. Sorry, I could.
4, 3, 2,
because I could go
1.
1, 2, 3, 4. Yeah. Okay. So never mind. Sorry. In any event, I think these are both always shaded. in either
I
case.
think,
Because you
yeah.
need the 2 to be part of the thermo, I think. Let's see.
Yeah, I think you're right. I think you can go ahead and shade those 2 cells.
Uh, uh, yeah, so either the 4 is shaded, in which case it has to go 1, 2, 3, 4, or the 4 is unshaded, in which case it needs to go 1, 2, 3, 5. And so in both cases, I think actually all 3 of these are shaded. I think. And this is only because, so you could do something like this. There's nothing to stop you from doing something like that innately. The problem with doing that is that there's a 1 in row 1. And so I can't make this a 1, and so then I can't make my length 4 thermometer anymore. So I think I can do that. Which means that actually, because the border connects, I either run across here or across here, meaning the one that's shaded is either at the top or bottom of this column, meaning these are all unshaded.
Wait,
like that.
how does that follow?
Because the border of a yin yang is connected. So the shaded cells either connect around there or connect around there. And so either way, so this cell or this cell is shaded, and there's only one shaded cell in the column.
Yep.
So these are all unshaded.
I thought it had something to do with the thermo, and I was very confused, but it's just yin yang.
No, it is that is pure yin yang, yes. Yeah, one of the shaded cells is at one of the ends. Yeah, the 1 thermo is not incredibly restrictive. I will concur with that assessment. I can fill in things like this is a 3 or a 5 that are somewhat restricted. Oh wow, yeah, Jay is right. This is always 5. Because remember, there's sort of 2 universes. One of the universes is 1, 2, 3, 4, and the other is 1, 2, 3, 5. That's always 5. Good spot. So these are always 2, 3, 4, and that one's not 4. That one's not 3. That one's not 2.
Wait. Why couldn't it be like? Why couldn't column 5 be like 1, 2, 3 going up, and or sorry, 1, 2, 5 going up with the 3 at the top? I don't see the
because
problem with
those
that.
aren't in thermo order. 1, 2, 5. That's not 4 cells.
Oh gosh.
This is also 1 or 3, funnily enough, just by looking at the cells that see it. So that's a 1, 3 pair. So these are a 2, 5 pair for whatever that is worth. This is a 4 or a 5. I wasn't intending to mark the whole grid, but we're almost there now. Let's see. I feel like it should be clear to me which of these things happens, whether it's those are all shaded or those are all shaded. But I don't know. Because the only really restrictive thermo is the length 3 one. Is the issue with, so if the 3 is shaded, then I'd have to go 3, 2, 1, I guess, is the only thing I could do. Because I can't do 3, 4, 5 in this column. There's no way to make it work. So if this 3 is shaded, these are all shaded, and it's 3, 2, 1. if the 3 is unshaded, then we'd have to do 2, 4, 5 shaded coming down like that. Makes the 2 by 2 of unshaded. Couldn't this still be? Oh no, oh, okay. So the problem is if this is shaded, then we get all of this is shaded. Oops, sorry. If this is shaded, then my shading ends up looking like this. And now I've got to get something into this 2 by 2, which I guess, yeah, which I can't do because this is definitely unshaded, but this is also definitely unshaded. So in fact, actually, just by my number clues, all of these 3 are unshaded, and so that's a 2 by 2. So this can't be shaded, it's unshaded, which then forces shading all the way around. The avoid a 2 by 2 forces that to be shaded. This is unshaded by the number clue. This is unshaded by the number clue. 5, 3, 2, 1 means that's a 5 and a 2. It's a 5 and a 3. 4, 3, 2, 4. And let's finish the shading. So this has got to go 2, 4, 5. Coming down has got to be my thermo. And now 4, 5 or 4, 3 both work. But that yellow has to connect. And in fact, that's my last yellow. And so that is a 1. Very cute. Yeah, I was only waiting to fill in row 2, column 2 until I had finished the shading, because it feels weird to have the answer check trigger before you have finished the puzzle. And it felt like the shading was an important part of the puzzle. And so there we go. There's our little 4. Thank you for that, Dorlier. And I hope the baby and mother are doing well, as always. But yes, I think that is going to be it for a stream today. Thank you for everyone for putting up with our horrible technical issues at the beginning of stream. It was not completely ideal, one might say.
Yeah, I'm gonna have to.
Thank you to both Plonk Time and Tall Cat for the donations. Greatly appreciated. And thank you all for hanging out. You're going to fix your mouse, it sounds like.
I'll have to figure something out. I've been fiddling with it, but I haven't figured it out yet.
I see. Please do like the stream if you have not yet done so. And thank you to everyone who supports the stream in whatever way you do. If you want to support the stream, you can do that for as little as $5 a month by clicking the join button down below. And we try and help you out with some Zach emotes and a cool windmill designed by community favorite Echoes. So thank you, Echoes. And enjoy the windmills to all of you who have it. That's where the green screen names and all of these things happen. Also, plenty of people prefer to support on Patreon for whatever reason. We are equally happy with that. So thank you to everyone who supports. And I like to read off the names of the incredibly generous people at the top level. So at the end. So thank you, David, Nordy, Franco, Daniel, Danita, Nell, and Plonk Time. Thank you for your incredibly generous support. Thank you, everyone. And I'll see you all very soon.
Yep. See you soon.